Hello, dear audience. A very warm welcome and moin from Hamburg. We are so happy that so many of you can join us here today for our ALBIS online event, Driving E-Mobility Solutions. Today, we would love to share with you inspiring insights into the future of mobility and discover how plastics are at center stage. Explore with us the vast world of opportunities in the e-mobility sectors. Great to have you here with us. I hope that you're making yourself comfortable in front of your screens. We are here in the Hamburg studio and we are ready to go. So let me first explain how we will go about this afternoon. You can see the agenda of the talks today on your screen. But let me just summarize that we will have some opening remarks with Horst Klink, the CEO of ALBIS, followed by our keynote talk on the topic future of mobility and the paradigm shifts that it will entail. We have Dr. Stefan Carsten here in order to do so. He is an expert of future of mobility from the Zukunftsinstitut. Now, the core of our event will be 5 presentations, and they will be followed as follows. First, we will start with, Are you facing burning issues? This is a talk given by Sarah Luers from LANXESS. And that will be followed by another talk from MOCOM. Kurt Maschke will tell us all about the fact that one size fits all was yesterday. And then we will have a well-deserved break of 15 or 20 minutes from 2:45 till just past 3. At 3:05, we will meet again, and we will meet here reflecting. I will be reflecting with Horst and with Stefan what we heard in the first 2 talks. And then we will carry on and have Nicolas Batailley here from SOLVAY, and he will talk about the fact that the future is electrified, lightweight, and sustainable. The next talk then is from BASF. It's Christian Eigl talking to us, and not only talking to us, but he also is bringing a live demonstration of the digital simulation support app. And then our last talk will be 2 people, actually 4 people, presenting from COVESTRO, talking on charging, storing, and distributing. And at the end of the day, just before 5, we will meet again here and reflect on the talks that we have seen so far. Now, dear audience, we would love to hear from you. We would really like to interact with you. So on the right-hand side of the screen, you can see that you can give us your remarks, your thoughts, your ideas, and they will come here to Munich, to Hamburg, into this studio, and I can forward them to our speakers. So we'd be really happy to hear lots from you. So come and give us your questions, and we deal with them. After the talk, if you want to review today's talk, do visit and come to our event platform, and you can review all the talks. You can visit our partner presentations as well. You can also forward this link to people you might know of and who can't make it today and who will miss this event. No problem, they can always revisit the site and then hear all the talks. So much for me, for the housekeeping rules, if you like, and now it's time for me to introduce you to today's host, who is Horst Klink. He is the CEO of ALBIS. Great to have you here today, Horst. Now, this, I think, is the 3rd of a series event that ALBIS is starting.
Right, yeah.
I know that there were different topics before. I think one was on sustainability, the next one was on healthcare, and now this one is on e-mobility. And this already tells you the broad range of topics that ALBIS is dealing with. So Horst, why has ALBIS now chosen e-mobility as today's focus?
Yeah. Thank you, Margit. First of all, it's a warm welcome from my side, and a big thank you to the entire team who has made this event happen. This includes our partners, and it also includes you, Margit. Thank you for guiding us and moderating us through this exciting agenda and afternoon. We are all very pleased that we have more than 200 external participants participating today in this event. Yeah, why e-mobility? E-mobility is a mega trend that goes hand in hand with sustainability. And for us at ALBIS, we would like to see e-mobility contributing strongly to this sustainability topic. We have been observing that some market participants have neglected sustainability for quite some time. And at the same time, ALBIS is well positioned and well prepared to address, to support, and to serve these growing market needs. E-mobility is growing rapidly, And with every industry sector that is growing, there are new and ever-changing requirements. And at the same time, ALBIS has been working on it together with the partners. And we all think it is very important to have this afternoon and show our participants, customers, how versatile and how colorful potential solutions in this area are, product solution as well as digital solutions.
And what makes e-mobility so interesting to your partners then?
Yeah, well, we see that this market is growing rapidly, as I mentioned, and we happen to be one of the world's leading distributors for engineering plastics, standard polymers, thermoplastic elastomers, and we do represent the who is who of the plastics industry. 5 of them are with us today, and as a result of this, we probably offer the best and most comprehensive, best-in-class product portfolio to the entire plastics industry worldwide. We have developed a very strong distribution and logistics network over the last 60 years. We have 24 locations worldwide, and we have 450 very passionate employees who go the extra mile for our customers. Our headquarters is here in Hamburg. It's not in the studio, it's just down the street. And we have a very strong presence in Europe and a growing presence in North Africa, but also in China and Southeast Asia.
So, truly global thing. And I know that you personally, you've been in touch with the partners we're going to learn about today as well. You even worked with them in your career, is that correct?
Yeah, well, that is correct. Of course, not with all of them.
Well,
we have some 20 principals. We refer to them as partners. I simply stayed with one business and worked with 3 producers over time. I then changed to a global plastics recycler, moved on to a global compounder and distributor before I joined ALBIS 4.5 years ago. And yes, I've been around. I started in Germany in sales, moved on with a growing responsibility to India for 4 years, and then to Brazil for Latin America, then to the United States. And when we returned from the US to Germany and safely grounded our family back at home, I spent a significant amount of time in Austria, in the UK, and also in China, always with a very strong focus on customers. And that is exactly the strength of ALBIS. We proud ourselves that we can offer to our partners and to our customers a very strong and very good market coverage, a very efficient business relationship, and a good strategic fit with the right technical know-how that matters to customers and to partners. And we have this in our DNA that we fight for every single kilo, and it's fair to say that we can support a global international key account as well as a small and medium-sized injection molder.
That's great. So looking at this very wide and also long experience, are there 1, 2, 3 solutions or applications that always spring to your mind that you remember?
Yes, there are a lot more than just 1, 2, or 3, but thinking of e-mobility, there's one that comes on my mind which we like a lot when we have various and multiple product solutions in one project. Well, this is a nice value add for distribution where we can really play with our product portfolio. And to cut this a little shorter, I would like to invite everybody to participate and visit us at this year's K-Show. This is our single largest event in the plastics industry. We have about 30 exhibitions this year, but you will see a lot of new and exciting applications at our booth in Düsseldorf in October this year. That would be very nice to talk about more in person rather than in a digital way.
That sounds really exciting. Now, if we think about, we have the keynote speaker coming up. Before he tells us all about the future, how about your view to the future? What do you think are the current drivers and the current trends with e-mobility and on the e-mobility market?
Yeah, of course, there are many. And to me, this is the transformation of an entire industry. We would like to guide and support our customers in this transition. For me, and I'm quoting Stefan here already, this is much more than just about cars. It's about anything on transportation that moves us from A to B in an already very digital world. It's simply the future.
So much more than cars. It's really the cars that always spring to our mind. But a friend of mine went to Norway the other week, and she used a ferry, an electronically driven ferry, and there was this giant plug that was plugged into this giant socket, and that was really interesting. So yeah, let's open our minds when we think of e-mobility, because there's so much more to it. So when it comes to visions and progress, who is there better to talk about all this than Dr. Stefan Carsten, who I very much welcome here today in our studio. He is here on our virtual stage. He is a futurologist, and I'm very proud that I can actually pronounce this word. And he's also an urban geographer in Berlin. And as a consultant on future issues, he supports organizations in their way to sustainable futures. Now, Stefan is a driving force behind several innovations of mobility services. And he has designed mobility services also for Daimler, which is actually something we all know now in the cities around the world. And since 2019, he is cooperating with the Zukunftsinstitut, where he publishes the annual mobility report. So, Stefan and Horst, so great to have you here. And Horst, I know that you are particularly keen on listening to what Stefan is going to tell us. So why have you invited, or why have ALBIS invited Stefan of all people today?
Yeah. Well, you already indicated Stefan is an industry expert, and he has that specific expertise that we believe is important to our customers. And Stefan, unlike us, I would say, has this visionary view. We do have, if we're honest, we do have the habit to once in a while forget us in this day-to-day details on techno-commercial solutions. So you have that visionary view and the overview, which is exactly what we need right now.
Thanks a lot.
That's great. Also, Stefan is great to listen to. He's great to be with, to be honest. Yeah. So great having you here today. And Stefan, when Horst was telling about how ALBIS was a pioneer really in sustainability, I saw you nodding frantically. Do you think ALBIS is on the right way there, on the right track to the future?
Well, thanks a lot. Thanks a lot for inviting me here on stage. Yeah, definitely. I mean, I'm a futurologist, as you have been perfectly pronounced. When I'm invited to talks, when I'm invited for consultancies, it's never about the internal combustion engine. Never again. This is an old technology that was very important for Germany, and worldwide it was the most important driver for our wealth and where we stand here at the moment. But from now on, we should focus on the future, and from now on, we should focus on electric mobility, because old technologies phase out. Sometimes we are not so good in Germany in identifying new technologies, but here, being with you, being with ALBIS, is a great opportunity to really strengthen the idea of what electric mobility is all about. And yeah, well, as you already said, yeah, it's about mobility. It's not about traffic or transport anymore. And what this means, I'm happy to show you later.
Now, before you do so, let me know, the personal, private Stefan, where do you touch e-mobility on your everyday life?
Yeah. Well, I'm from Berlin. I'm unfortunately not from Hamburg, but traveled here with German Rail, obviously, in the morning. I'm living in the city center of Berlin, yeah, where all the mobility options are around. And I'm using heavily car sharing because I wrote the concept for Car2Go some years ago. And I'm heavily try to understand what kind of car is part of the car sharing system. Is it an electric fleet or is it a traditional fleet? And to be honest, I use the electric versions pretty much because it's so much fun to drive these new products. And this is what customers are telling me all over the world. 9 out of 10 customers who first experienced electric mobility are saying, I will never drive this old technology again. I will go with electric mobility from now on.
That sounds like a lot of fun with it as well. So let's dig into your keynote then. The floor is yours.
Thanks a lot. Thank you.
Thank you, Stefan.
So we have been talking about the transformation of the mobility arena, and I would like to highlight in my next 15 to 20 minutes, and I know that I'm only the introductory speech to all these very, deep dives into your markets and into your technologies. But I would like to highlight 3 paradigm shifts. And we all know that electric mobility is definitely also a paradigm shift, as I was already mentioning just before. I would like to start with my first paradigm, which is more or less a little bit of a spatial framework of what is happening currently, not only in Germany, but in Europe and all over the world. So I'm waiting for my first slide to, yes, here we are, perfect, thanks a lot. So I'm an urban geographer, by the way, and one of the most important paradigm shifts that have been identified more or less during the corona pandemic, and I've been involved in this trend since more than 10 years, is road diet trend and all what comes close to active lifestyles. And I would like to present you a little journey through Europe, and I would like to start here in a small suburb of Brussels. And this small suburb is, I think, very typical for any small suburb or small city or even bigger city that we are living in all over the world, but at least in Europe as well. And if you look at this place here, you can see in the small inlay how this place looked like 5 to 6 years ago. It was, as usual, a parking lot. And many people are saying a parking lot in a city is the most inefficient spatial entity that we could think of. Today, it's a place to meet, it's a place to gather, it's a place where kids are cycling and playing, it's a place where we have tram lines at the edges, which is hardly to be seen, and it's a place where the retail that is along this place is very, very happy today, because retail revenues have been going up after the transformation of the place, while we'll see many places and many inner cities today with a lot of parking lots where retail revenues are going down. It's a place where people can talk about business. It's a place, I think, what is very prominent for the knowledge society to come. We have been living in cities for the last 60 to 70 years, which have been focusing on industrialization. The next phase is about the knowledge industry, and this is why cities all over the world are now restructuring and transforming their cities and the idea of what a city is all about. And one prominent example, before I then come to mobility, is the city of Heidelberg. Heidelberg has been in the New York Times last year on a DIN A4 sheet of paper with a statement, "We are the city where cars are not welcome." And they are not doing this to support cyclists. Well, they're doing it to support cyclists, but this is not the primary issue. They are doing it to economically survive. So they understood that there are new rules for economic growth and there are new rules for investment strategies in cities. And yes, we are part of a great competitive arena in cities as well. And cities try to cope for new, or to invite for new industries, for new population, for tourists. And Heidelberg is only one out of many examples where city and mobility has changed and will change in future. What does it mean for mobility? Well, it means that active lifestyles, that cyclists will be probably the most important means of transport in the future. We have seen an unbelievable growth during the corona pandemic. If you want to buy a bike today, it's hardly possible because of logistical issues. Electric mobility, so cargo bikes and bikes who are powered by batteries, are the main important trend. Cities who have never experienced cyclists in the past, such as Zurich, for example, in Switzerland, with great topographies, are now cycling cities because you have electric-powered vehicles of any dimension, yeah? 3-wheelers, 4-wheelers, 2-wheelers, but you have to use your own muscles, your own power to go ahead. These cities are now understanding that living in an healthy city, an active city, is very important, not only for the citizens, but for the whole societies. As I said, retail is profiting to a great extent, and one of the major drivers is that we see cargo bikes not only for families, not only for private purposes, that we see cargo bikes for all kind of cargo and economic purposes as well. Today we have in Germany about 5 billion parcels, and the trend is continuing to grow over the next years and decades to come due to online shopping and e-commerce, of course. And we see more and more players who are now involved in cargo bikes for the last mile, for parcels, last miles, for doing mechanical engineering, for customer relationship management, and so on. So, in the city of Munich, just to give you this small example, the whole parcel amount of UPS will be serviced on cargo bikes from this year on, and this is only the beginning. So electric mobility will be in cars for sure, but it will be in many other vehicles as well. So I'm coming to the next paradigm shift, and this paradigm shift addresses the public transportation sector. And it is the understanding of not only carrying people from A to B, but providing mobility everywhere you are around. So I conceptualized Car2Go 15 years ago, and I conceptualized Movil as well 15 years ago. So Movil is the idea of mobility now and everywhere. So I made a study 2 years ago at the beginning of the Corona pandemic together with Ford, and we wanted to understand how the young generation is perceiving mobility and how it defines mobility. And for me, the answers has been astonishing. To the question, what does mobility mean to you? The young 18 to 23 years old answered, well, first of all, it's flexibility. Second, independence. And third, it's freedom. So how is this being translated into mobility? Well, the older among you, and I consider myself old enough to say the same, we know these terms, we know these approaches. Yeah, these have been for decades been put together with a car. The car is flexible, independent, and it makes me free. But for the young generation, it is not the car. In their daily mobility patterns, it's walking, it's using public transit, it's using a car, either my own or a sharing car, it's cycling or using public transit for remote locations as well. So, as you see, for decades we have understood that the car defines the system of mobility. At least from now on, we need to understand, yes, the car is part of the system, but the mobility system is much more. It's mobility everywhere. And I would like to show you and explain to you this very weird-looking graph on the right side of my slide, because it shows you how young the mobility market is and what mobility means for service provider and for players in this arena. If you just look down to the last 6 colored lines, yeah, at the bottom of the graph, this is the status of mobility in the year 2000, so 20 years ago. We had the choice of using our own car. We were able to use public transit. We could walk. We could use a bike, a cab, a taxi. And in the city of Berlin, at least, we had a station-based car-sharing scheme already, Stadtauto, today Greenfields. All the other lines have been added since then. So in 2000, we had 6 options to move. Today, we have 30 plus options. And this is mobility. Mobility for me is not only to be mobile, it means options, it means choice, it means alternatives. And only then I can decide, well, it's raining today in Hamburg, well, the sun is shining today in Hamburg, so I use my bike, or I take a car, or I have a meeting in the evening, I better use share now, and another option later. This is mobility, and as you can see on the left-hand side, this is where I live, the blue dot is where I live, there are all the options. So I decide every day on my own how to move the city. So car sharing, one of the biggest automotive OEMs asked me last year when I did a great study with them, so Mr. Carsten, car sharing is over now. Now we have Corona and car sharing is dead, isn't it? And I said, no, I think it's just the beginning. I think it just has started. And you can see it on the left slide. These are the growth prospects over the next 3-4 years, car sharing market worldwide. On the right-hand side, you see where car sharing is already now present in Germany regarding the size of the cities. Yes, it's everywhere in every city greater than 100,000 inhabitants. But when you look on the small diagram, 5% in cities smaller than 20,000 inhabitants, I think this is what is happening now. Car sharing is now entering the rural landscapes. It's now entering villages, small communities, because it makes sense, even today economically, to have a car sharing scheme in these cities and to make use of it. So, just to give you some figures when we speak about this, the sharing capitals of Europe, Paris and Berlin, they have approximately 50,000 vehicles even today, on-demand sharing vehicles even today in the streets of Paris and Berlin. And I'm happy that Hamburg is already here on rank 3, I guess. It's very close together with Rome, but it's on rank 3 with approximately 25,000 vehicles. The predominant amount of these vehicles is electrified. And yes, we will see more and more of these vehicles in the future, not only in the city centers, but at the edges of the city, in the suburbs, and as I just said, in the countryside as well. So, on-demand sharing is part of the mobility scheme. I see expansion plans by almost every player in this arena. I see investments in almost every player in the game, and the game is changing. That's for sure. And we need a new understanding of how we service these mobility options. Today, we all complain about scooters and mopeds who are lying around on the pavements, on the sidewalks, and the pedestrians need to walk over these. And we need to understand that we need a spatial and digital organization of these. And I think mobility hubs are one of the greatest driver and one of the greatest designs and architecture that I'm looking forward to welcome in our cities, to give access to mobility, even if there are no mobility schemes there right now. So I think almost at every public transportation stop, we will see somehow any kind of a mobility hut, either with colored lanes or even with new architecture. And I'm looking for these futures because these are these are the next stage of what we refer to be a gas station. The gas station will be the mobility hub of the future, where you do charging and meeting and communication and try to be mobile. So I'm coming to my final paradigm, and this is obviously the future of the car, of the individual car, and it's a paradigm of one great transformation that we are facing even today as well. And I would like to introduce to Sharon. Sharon lives in a small gated community, which is also part of the story. It's a gated community in Florida, and she's blind. She is not able to move unless her husband is driving her around, or unless an autonomous vehicle picks her up and drops her off where she needs to do her daily errands or where she needs to visit her husband. What do you think? Just a small question that you can think about, and I think most of you are well aware of what is happening. When is autonomous mobility coming to Germany? Is it this year? Is it in 2 years? Or is it in 10 years? I give you a second to think about. And yes, of course, autonomous mobility is coming this year to Germany. In Munich, we will see the first robocabs. And it's not the established automotive OEM who are running the service. It's Sixt, the rental car provider. It's Mobileye from Israel, and it's Moovit from Israel, who have a joint cooperation and who will start in the whole city of Munich their RoboCab services. Just to give you some understanding of where we stand here at the moment, the best service providers are now capable of drive roughly 50,000 kilometers without a human intervention. So 50,000 kilometers just based on algorithm. And after 50,000 kilometers on average, the human driver has to intervene because the red light is not well detected. And so these are dimensions that makes me feel safe to drive with such a vehicle and to be in a city with these vehicles. We need to understand that with autonomous vehicle, old definitions and old approaches and perspectives will change. Am I sitting in my private car? Am I sitting in a public serviced vehicle? Is it a mobility service provider? Whom am I paying for? Do I need any access? Do I need one app, several apps? Everything will be changed, and to be honest, I think this is a great chance, especially for the countryside, to integrate people and to bring them to public transportation stops. It's a great challenge and threat for cities, because you can imagine a future where you have thousands of robocabs in the cities, and maybe you don't even have to pay for the service because you are confronted with commercials or you are taking part of a survey. So the logic of the internet is now coming into our streets. What this has to do with electric mobility, I think it has a lot to do with electric mobility because electric mobility is a driver, enabler of these technologies. Here you see the cost structures for an electric vehicle battery package from 2010 until 2030. We are currently around $100 per kilowatt hour, which is exactly comparable to the prices of the old fossil combustion engines. From now on, batteries will get cheaper and cheaper and cheaper. So this is a driver for electric mobility to come. Just to give you an insight and where do we stand at the moment, here are figures from 2020 compared to 2021. You see China, Europe, and the United States. You see growth rates everywhere in all dimensions, that's for sure. You see battery electric vehicles, you see plug-in electric vehicles. Just to fully understand me, for me, plug-in vehicles are not electric vehicles, and this is why the funding and promotion of plug-in vehicles will phase out probably at the end of the year in Germany, because we have a very weird situation currently in Germany. We have the market share is 50-50 between battery electric vehicles and plug-in vehicles. It's only because of subsidies and funding and political support for the old players. It has nothing to do with the technical requirements and possibilities and options to come. Yes, we have a shortage of charging, and we have a great shortage of charging. At the moment, we roughly have about 50,000 slots in Germany. There's, to be honest, no one knows the exact numbers, because we have counting and every institution counts differently. And we need approximately 800,000 slots which are publicly available in the year 2030. So this is, I think, a great market, and it's a great need for these charging infrastructures to come. And yes, if you're still driving an old combustion engine, you may go to your gas stations where you normally get your gas, where you normally buy your beer or your milk or your chips. And you could go there in the evening and could say, okay, maybe today was the last time I've been at your gas station, because a gas station will phase out as well. And it could be either a mobility hub, a kiosk, or a supercharging station that we definitely need. So just to sum up, the future of mobility, yes, it is very likely that we see less cars in the streets, at least less cars that we own, because every city is now removing car space, is now removing parking lots, is increasing prices for cars, because they need to prepare for the knowledge-based society of tomorrow. We see much more options, not only in the city center, but all over cities and the countryside. And e-mobility and autonomous mobility defines the new standard. And my last slide, is a kind of inspiring slide, but it's very important for me to show you what is happening in other parts of the world. And just to sum up, this is China, and this is the city of Zhonan. And this city is being built in this second. And the Chinese president, Xi Jinping, when he opened the construction site last year, he was saying, welcome to the city with no streets and no cars. And this is a city that is based on neighborhoods, 15-minute neighborhoods, and the predominant modes of transport will be cycling, it will be walking, and yes, it will be autonomous vehicles, autonomous concepts for waste disposal, for bringing one to the public transportation scheme, and so on. Here, 5 million people will live. But Xi Jinping also said this is the blueprint for the next 400 to 500 million urbanites to come in the next 20 to 30 years. So this is a blueprint of the future, and it has nothing in common with old cities and old ideas of mobility and transport. Thanks a lot.
Oh, thanks so much for this really, really inspiring talk. Also to see the future there, which very much looks very, very different from today. Yeah, thanks so much. I think that is inspiring, and also thanks for staying with us. So during the other talks, we can always come back to you, Stefan. Thanks for bearing with us. We actually have 5 minutes. I didn't warn you about it, but we would have 5 minutes for your questions, dear audience. So you can give us your questions. And I, for one, have one question to you. So if you look at the scooters, the e-scooters today, in the city. You can, as you said, they are basically everywhere and they are a nuisance, to be honest. And I think they come on top of all the vehicles that are there already.
Yes.
And all this car sharing business, at the moment they come on top of our private vehicles. Where's the point where they don't come on top, where they actually replace the private vehicles? Can you tell?
Yes. No, of course not. I don't know the months when it will be exactly the spot. But it is very important to observe that, as I said, it's a very young market and people are still uncertain. Will it stay? How will it evolve? What does it mean for my mobility behavior? And yes, it is already changing in the inner cities. We have very low motorization rates in the inner city, but there are even more cars in the edges of the city and in the suburbs. Yeah, that's part of the story as well. We see cities like Paris, for example, they are very strict on certification rules for scooters. There are only 3 suppliers in the whole city of Paris, and they are all certified by means of sustainable drivetrains. So only the best providers and service providers are allowed to service in the city of France. And we will see definitely the same in all other cities as well. I don't know whether next year or maybe in 4 to 5 years there will a mindset change happen as well. I think when the space in the city will change and I have no private parking in the public anymore, then behavior will change dramatically.
Now, the scooters, at the moment, they are not supposed to be very sustainable, are they? Because I think their lifespan isn't very long. And now, because here at this event today, we're talking about materials a lot. How can I make the scooters live longer? Could they live longer? Are they just being dealt with very badly because the users just throw them everywhere? Or?
To be honest, it has been a disaster, let's say 3 to 4 years ago. Yeah, there was no idea of what a product like this should be designed for, and this has changed. Yeah, even today the lifespan is much longer than compared to 4 years ago, and they are more sustainable in this respect. We see a lot of cooperation between scooter providers and the public transportation agencies in cities. So players who haven't talked to each other for years and have said, no, I don't want to, they are now coming together to provide better vehicles, to provide better products, and to provide better services for the citizens. So yes, in this circumstance, I'm rather optimistic that we see better products and more sustainable products.
Great, thanks Stefan. See you later here. Dear audience, keep these questions coming in because we will bring them forward in a minute or later. After the break, Stefan will be with me here again and we will reflect on the other talks. And so for now, I'm very happy to come from all this hot stuff that Stefan told us about to another hot business. It's the talk by Sarah Luers from LANXESS, and her talk is all about the burning issues. So where is she? She will come fly into the studio in a minute, and she will tell us all about her title. The title is Are You Facing Burning Issues? Evolution and Processing of Flame Retardant Materials for EE and E-Mobility Applications. So, Sarah, are you here with us? Okay. Is she in? Okay, we're waiting for a minute, are we? Okay. Just takes a minute for Sarah to dial into the program, and then you will see her next to me, appearing out of nowhere, if you like. And remember to already give us your questions, because after Sarah's talk, we can take these questions in directly, and then you can ask her directly. Maybe ask her, maybe give her some ideas, share with us your ideas on e-mobility and the burning issues about flame retardant material. I know that Sarah has already dialed in, so it's only a matter of seconds that we can see her here now, and some things going on the screens here already. Okay, here we go. Sarah, on to you. Thank you.
Okay, yeah, welcome from my side as well to the ALBIS e-mobility event. And thanks to ALBIS for letting LANXESS participate in this event. Today, I'm going to talk about the evolution and especially the processing of flame retardant materials, which are used for E&E and e-mobility applications. But before we start, let's have a short look at the agenda. So I will start talking about LANXESS itself and a short portfolio overview. And then I will dive deeper into flame retardants, which are used within polyamide and PBT. And finally, I will show you some application highlights with our flame retardant materials and where they are basically used. So LANXESS high performance materials, we are basically a business unit of the chemical company LANXESS, and we are one of the leading suppliers of engineering plastics. This basically means that we sell our materials under 3 different brand names. One of our brands is Duracane. Under this name, we sell our polyamide, meaning PA6 and PA66 based materials. Then our second brand is called Pokane. Here we are talking about PBT and PBT blends. And finally, we also have the brand Tepex, with which we mean our long glass fiber reinforced composites. However, these Tepex materials are not sold via ALBIS. So in case you're interested in these materials, you have to come directly to us. Via ALBIS, we sell our Duracane and Pokane materials. And this will also be the focus of today's speech. To give you a very short introduction into our materials, let's have a look at our product portfolio. Here on this slide, you see our the characteristics for our PA6 and PA66 grades. All of our PA6 and PA66 grades have some general characteristics. They show excellent mechanical properties, very good resistance to heat, to chemicals, and also to abrasion. And we can even fill our PA6 materials up to 60% of glass fibers. Maybe more important for you are the special benefits that we can generate for our E&E and e-mobility applications. Here we are talking a lot about flame retardant materials, and our materials typically fulfill all the general specifications like V0 or V2. We do have materials which are containing halogen flame retardants or also ones which are halogen free. Then we have some special grades which show very good warpage properties and also heat and electrical conductive grades. Last but not least, all our materials which we use within the E&E and e-mobility industry contain halide-free heat stabilizers with a very good temperature resistance up to 200 degrees Celsius. Similar picture for our Pokane brand. Also, PBT and PBT blends show some general characteristics like excellent resistance to heat and chemicals, very high abrasion resistance, and due to the fact that PBT doesn't take up moisture over time and under heat, all of these properties stay pretty much stable even at high temperatures. Again, we develop special grades for the E&E and e-mobility industry, like flame retardant materials, like hydrolysis resistant materials, but also grades with very good flowability or very good electrical insulation. This was very briefly what we can offer and what ALBIS can offer to you. Now let's dive a little bit more deep into the topics that we want to focus on today. Let's start with our flame retardants. First of all, you can ask the question, why is it so important to have flame retardant materials? Well, this is pretty easy because the importance of fire safety is continuously increasing, especially in the E&E industry, but also in e-mobility, where passenger safety is becoming more and more important due to the fact that we have more electrical applications within a car. At the same time, this using flame retardant materials also increases the complexity for the engineering plastics, like environmental properties, but also, which is very important, to maintain mechanical and processing behavior. So let's have a look at what it does mean to have flame retardant materials. So when you look at the heat release of some plastics, like for example for polyamide and PBT, this heat release corresponds to that of combustibles. So you see here that the heat value of PA and PBT is similar to the one of black coal. What does it mean? It actually means that in order to achieve flame retardant properties within a polymer, a massive modification of the formulation is necessary. So you have to add certain additives to make the material flame retardant. And at the same time, you want to achieve you want to fulfill all the test regulations. And in the best case, you for sure want to maintain mechanical properties as well as processing characteristics, because you don't want your flame retardant material to be less performant than a material without flame retardants. So, but what can flame retardant materials actually achieve? Or what can flame retardants achieve? When you look at the flame spread, so actually what is happening when a flame or when a fire is generated, you have the ignition phase, then you have the phase where the flame is spreading, and finally you have a fully developed fire. Flame retardants, however, do only work in the beginning. So as soon as you have a fully developed fire, it doesn't matter that your polymer is flame retardant, then it just burns down. But in the beginning, flame retardants can work, and they can act in the starting phase of a fire to kind of slow down the flame spread of the material or of the fire. And for example, give passengers in a car more time to leave the car before the fire really starts. What kind of flame retardants do we have? Or let's rather start with the mechanisms that we have. At this stage, I have to say I'm not a chemist, I'm an engineer. So if you really want to dive deep into the chemical processes, then I might want to refer you to one of my colleagues. But when you look at the mechanisms, basically you have different kinds of mechanisms. You have a radical combination, you have intumescence, you have fire-inhibiting gases, and also matrix depolymerization. And all of these mechanisms that you have aim at slowing down the fire. So with some mechanisms, you generate some kind of layer, like a char, which puts out the fire. Then you try to get rid of the oxygen in order to slow down the fire. So basically, all of these mechanisms aim at putting out the fire, or at least reducing the velocity of the flame spread. And this can be done by different kind of flame retardants. Like I said, we do have halogenated flame retardants, but we also do have halogen-free flame retardant systems, like the phosphorus-based ones, the inorganic-based ones, or the nitrogen-based ones. And typically, you often don't have only one flame retardant system, but you often have a combination of different flame retardant systems, for example, with some kind of synergist. And by this, you then also have different mechanisms working depending on which flame retardant you choose. So what are the difference between halogen and halogen-free flame retardant systems? because this is one of the questions that we are often asked. So halogen contain, and there is actually no black and white answer to this. Customers also often come to me and say, okay, we want to make the switch towards halogen-free solutions, and they expect to only have benefits. Well, actually, they do have a lot of benefits, like they have better electrical properties with halogen-free FR systems. They have a better long-term heat aging performance, and they also have less discoloration in heat and UV light. However, at the same time, with halogen-free flame retardant systems, you also get some disadvantages, like higher impact on mechanical properties and a smaller processing window. In comparison to that, halogen-containing flame retardant system show very good performance when it comes to the glow wire index and a very low ignitability, especially in polyamide, and a higher thermal stability during processing, which means that you have a bigger processing window. At the same time, halogen-containing flame retardant systems show higher density and a negative reputation in the public, mainly due to the use of antimony trioxide as a synergist. And especially this negative reputation in the public is the reason why a lot of customers move towards halogen-free flame retardant systems. And as I said, there are a lot of disadvantages, but you also have to look at, there are a lot of advantages, but at the same time, you also have to look at the disadvantages. And one disadvantage I can show you on the next picture, when we look at the side effects of flame retardants. So for example, when you look at the polyamide or PBT without flame retardants, then you have a processing window that somehow ranges between 250 to 300 degrees Celsius, always depending when the polymer melts and at which point the polymer starts to decompensate. However, in polyamide and PBT without flame retardants, the decomposition starts way above 300 degrees Celsius. So you have a pretty wide processing window. However, as soon as you incorporate flame retardants in your system, you limit the processing window. Because typically, especially halogen-free flame retardant systems start to operate between 290 and 400 degrees Celsius. And that means that you always have to make sure that your material stays below the 290 degrees Celsius, even in processing. That means in the end that when you use flame retardant materials, you tighten your processing window. So now, after all that you've heard, you probably wonder why you should even use flame retardant materials. Because I'm only talking about the complications and how the processing window gets smaller and so on and so on. However, within LANXESS, we aim at developing new materials that somehow, try to go around these disadvantages and that give you a solution even with these challenging materials. And I want to give you an example. Looking at the improved thermal stability of flame retardant materials. And what you see here is a comparison of a state-of-the-art PA6 GF30 with a halogen-free flame retardant system on the left side, and our Durethane BKV30 FN04, which is also a PA6 GF30 with a halogen-free flame retardant system. But within this grade, we managed to improve the processability of the flame retardant system by using optimized combinations of flame retardant systems and also by improving flowability. And by doing that, we managed to significantly reduce the mold deposit, because one of the challenges that customers often see with flame retardant materials is that due to the also smaller processing window and also due to the additives that are within the flame retardant package, you see some mold deposit, which you can maybe see here on the picture, on your mold. And by using our newly developed, or let's say state-of-the-art material, urethane BKV30FNO4, we managed to develop a material that significantly shows less mold deposit. And this is only one area which I wanted to show you in this short time, where we managed to develop materials that show better processing behavior, even by using flame retardant materials. Similar developments we have when we talk about wear topics and also processing windows and so on. So even though flame retardant materials might be challenging at first sight, there are always options and developments in order to stabilize also your processing. Okay, and now maybe the most interesting part. Now I want to show you some application highlights and where we use our flame retardant materials. So you might think, okay, where do I actually meet flame retardant materials? And to be honest, you always have them around you. So wherever you are going, you always face materials with flame retardant systems. In this case, just have a look at your home and everything around. Here you can see, or I will show you, that you're actually surrounded by flame retardant materials in order to increase also your personal safety. For example, when you look at e-mobility, this is probably the fastest growing industry that our materials are going into. And within e-mobility, we have a lot of applications with flame retardant materials. One of them is a high voltage connector, which you see here in orange color. And well, typically these high voltage connectors have to fulfill certain requirements like mechanical robustness, flame retardancy, high tracking resistance, but especially also this is a significant orange color, which also has to withstand under heat. And we at LANXESS developed the urethane BKV45FNO4, which is a PA6GF45 with a halogen-free flame retardant system, which kind of fulfills all of these requirements that are asked for high voltage connectors. Another application area is, again, connected to e-mobility. Here we're talking about home charging. And for example, whenever you have an electric car, you probably also have a wall box at your home. And when you look at this wall box, it consists of a mounting structure. It consists of a lot of electrical applications. It consists of a cover. And all of these applications can be made from thermoplastic materials. For example, if you look at the mounting structure, also here, a lot of customers ask for a flame retardant material with a very good tracking resistance, and at the same time showing high warpage and high impact and low warpage, sorry. And for this, for example, a urethane BKV30FNO4, which, as I mentioned before, is a PA6GF30 with a halogen-free flame retardant system, can be used. And finally, maybe looking more at the E&E world, looking at your home appliances, for example, your washing machine, your dishwasher, or similar. Here, you often have a lot of switchers or connectors within these home appliances, and they have to show very good dimensional stability, good tracking resistance, and a very stable glow wire performance. And especially for this glow wire performance, we have developed a Pokane TFN4230, which is a PBT PET blend with 30% glass fibers and a halogen-free flame retardant system. And this material is VDE tested regarding the glow wire index and shows very good glow wire resistance. At the same time, being flame retardant and showing a good tracking resistance. So these are only 3 very brief examples where you are surrounded by flame retardant materials Actually, there are way more, not only e-mobility, not only home charging, but also photovoltaic applications are made from flame retardant materials. When you look into your fuse box at home, you will find a lot of terminal blocks or security switches where you have flame retardant materials. So maybe you do not directly see it, but actually in the end you are surrounded by them. And yeah, so this means it's also very important to further develop these materials. Now we come to the end of my presentation. I hope I've showed you that we are using state-of-the-art flame retardant systems within polyamide and PBT, and that we offer tailor-made solutions for basically every application. And with our experience in the area of E&E and e-mobility, we at LANXESS, together with ALBIS, can support you to develop new applications based on specific requirements. Thank you very much.
Thank you so much, Sarah. This is Sarah Luers from LANXESS, where she works with global application development. Now, thank you for diving for this deep dive into flame retardant materials. And I couldn't see any questions coming in, so I guess this has been a talk that was perfect to follow. But kindly enough, Sarah will be there to answer your questions. So you can still write them into the chat and she will answer them via chat, because also her line is a little bit weak. So her questions or your questions to Sarah will be answered on the chat. Now, let me just welcome those of you who've come in a bit late, and let me tell you that Sarah's talk, just as Stefan's talk, the earlier keynote speech, you can watch this, you can rewatch it loads of times on our event platform whenever you like. So nobody is missing anything here, but we can move on now to our next talk that comes to us from MOCOM. The next talk is from Kurt Maschke, and the title is One Size Fits All was yesterday, Customized Compounding Solutions for E-Mobility. So let me introduce Kurt to you. He's a German sales and marketing strategist in the automotive industry, looking back on some 27 years of experience. And in fact, he was one of the pioneers to note the trend of highly charged combustion engines and the need to develop different high-temperature polyamides, which are now broadly used in the industry by many system suppliers and car manufacturers today. Now, in his talk, Kurt is going to highlight the topic of changes in the automotive industry and the potentials for companies dealing with plastics, so your companies here, our audience, and the added value of customized solutions, including suggestions on materials for future applications. Now, this is where I have to spoil it a little bit for you, because at very short notice, Kurt couldn't make it to join us here today, but we recorded him, so you can still listen to his talk. And there's somebody else to answer your questions to Kurt, who is Thies Robel. He is in the team, in Kurt's team, so no worries there. But let's listen to Kurt first, and I guess the video will begin in just a second.
Good. E-mobility, customized solutions from MOCOM. First, let's start with a short introduction of the Autogrant Group. The Autogrant Group is a family-owned company. MOCOM is part of the Autogrant Group, as well also ALBIS as our distribution partner. Vipak as our recycling company dealing with plastic waste, and Kran doing distribution for chemicals. Let's have a look on some facts and figures. We are looking back on a 50 years compounding experience. We deal with roughly 5,000 customers, including the ALBIS distribution customers. We have more than 700 employees, and on this slide, I like to highlight that we get more than 1,000 development requests per year from our customers, which is more or less also here showing the customization, what we do day by day for our customers. MOCOM is global, means we have our production facilities in America. We have also different production facilities in Europe and also in China. And in all our production facilities, we do specialties, we do advanced and also recycling products. For all the different materials, we use the plastic pyramid, means all the polymers, what we see here, we can select and fit and modify in the best way, fitting to the customer requirements and doing the customization for our customers. Let's have a look on the MOCOM competences. MOCOM is well known for lighting, means special light effects, means light diffusing, light guiding, highly reflective, but also light blocking materials is what we do day by day. Means we do all customization in this direction, but not only for lighting, we do this also for a lot of other application fields, and especially also here for e-mobility. And by this, we always connect this to, for example, sustainable solutions. Means we can also select here an eco material versus a prime. We can also think in direction, also doing customization for lightweight. Means we use also here VPAC and also here plastic waste, for example, carbon fiber. In this case, to get also weight out of an application, then also electrical conductivity, thermally conductivity is really important, and all the measurements behind of these developments, and also wear protection, for example, if there's a special need for low friction in some application areas. Let's have a look on the drivers and the market situation, and in this case also connecting to e-mobility. For the automotive situation, if we look on the data itself, it looks not that impressive. Means we have a global growth of roughly 2%. We have in China a growth of 4%, and in the past, China was used to have roughly a double-digit growth year by year. Then also in Europe, in North America, we have more or less a flat situation. Means if you look on the data itself after the COVID situation, it's really flat in Europe, and it's also flat in North America, including also Mexico and Canada. Means from this perspective, is automotive not that impressive? But if you look on the next slide, then for the automotive situation, there's a rebuilding of the industry. Means there's now a clear connect to e-mobility, means full electric, the BEV, and also the plug-in hybrid electric cars. And all the different colors here on the slide are representing a different region, connecting with also here a full electric or plug-in hybrid car. And you see also there's a difference in the size of the bar, and this is regulations are driving, for example, for Europe, that there's really the bar really high. Means there's a lot of regulation pushing also here the e-mobility, and by this there was a CO2 fleet performance baseline in 2021, and then also reduction targets over the next years. Means in 2025 a minus 15% reduction target, and in 2030 minus 55. Means really tough in 2030, but also a lot of OEMs, they had difficulties to get to the target in 2025. This is the reason seeing at the moment a lot of e-mobility cars coming to the market, means fully electric, but also plug-in hybrid electrics. And in 2030, they have to do a lot to match the target there. Means it's minus 55% reduction. And by this, only the zero emission vehicles will count. Means only the full electric and some parts of the plug-ins, means with really low fuel consumption, will be counted herein. And also then lightweight will be also help to reduce the CO2, and also sustainable solutions. Means by this, the market itself will change a lot. Means from combustion engines to electric powertrain. And what we already know, that there are less parts in an electric car. Means there will be less parts, but with different requirements. For example, flame retardancy will be important for the cooling circuit. A lower temperature will be then open the door for different polymer solutions, and then also sustainability itself is really a push in the first choice for the most of the OEMs. For the infrastructure, it's a similar picture. If you look on the left side, you see the gas station, what we all know from today. And then also there will be multiple charging ways in future. Means for a full electric car, there will be an AC charging, there will be DC fast charging, solar charging, wireless charging in future, more and more what we see. And the nice effect for all of us is here that there will be a lot of plastic in use. Means for a gas station, there's not a lot of plastic in use. For a multiple charging way in future, there are many options for plastics, and this is then also related to different requirements like flame retardancy for the charger connectors, lighting for the wall box designs or symbols, and then also for sure for the infrastructure. Also sustainability is also here really important for these applications. Let's have a look on customization and what this means for us, for MOCOM. And I like to explain this at an example from Altrich. Altrich is our standard customized solution for you. Means by this we have a toolbox, and the toolbox is including a base polymer. And let's select the target more or less here on application like a charger inlet. And for this, it would be the base polymer, polyamide 6 or 6.6. It can be a prime or could be also an eco solution. Then there is a filler. We have to select the filler. In this case, a glass fiber, and could be in GF30. It can be also GF25 or 35. We have to select the colorant. Means in this case, it's at the moment, most of these applications are black. But in future, if a company likes to get also here an Altec Eco in, and they like also to show this to the market, it can be also green in future. And then we have to select an additive. Means here the package is then also here a flame retardant package to meet the requirement of an UL 94 VCO standard, which is then also needed for this application field. Means this is more or less the way of working for an Altec and customized solution for Altec materials, and this is always the same structure. And I like to point out on the Altec Eco that there's also here the need to calculate the CO2 footprint. And by this we use a calculation software, the GABI software, which is a calculation software used a lot in the automotive industry, also from OEMs. And the result is always communicated as a global warming potential. And on the graph, what you can see there is a comparison between a prime polyamide 6 GF30 versus an Altec Eco GF30 material. And this is roughly a reduction of 88%, means really a big step using an eco material versus a prime, which is really supporting also here what we saw before, all the CO2 targets in the market. The nice side effect is also that we can do this also in colors. Means we have always for sure to check this if the color is also here fitting to the eco portfolio. But in general, what we can do a lot of colorations there. If there are also some requests regarding colored eco materials, we can also move in this direction. For ALCOM, it's a bit different. ALCOM means always that there is a special functionality. It means there's more than only here putting some filler or some fiber or some color in. It's also here adding more functionality to an application. In this case, it's also here lighting with the light diffusing, for example, shielding effects, flame retardant combined with low moisture absorption is also here a topic. And if this is then also here the case, then we move this to an ALCOM grade. And here an example is our ALCOM EMI. It's a shielding material, means the base polymer is also here a polyamide. An housing application is, for example, an ECU or junction box housing, could be then also potential material than here. And the filler is here a special filler, really highly filled with 75% filler content. The colorant here is by natural black, means there's not a special color behind. This is black from nature. And then also the functionality here is really important, is the shielding behavior. And this is then also in an electric and magnetic field, means there are really some special requirements we have to fulfill. And also here to test, and if this is then the case, then you can also use this, for example, for such a junction box. Let's have a look on some application examples and also how they look today and also what we believe could be in future an option. For the battery casing, the status quo is quite simple, because at the moment, if you look in the existing cars, all of them are out of steel or aluminum. Inner parts, they are partly out of plastics, and also a lot of metal is there in the inner part. And support parts, they are also out of metal or plastics, means what we see here is a lot of room to also get also plastics in future in. What you see here, so these are then also examples from existing car models from 2020 and 2022. And if we now connect to what is a potential for us for plastics, you can also see this here on the picture, that there are then applications like the structural parts, means components and parts often or partly it can be out of plastics. The crash absorber is an application which is then also here a potential plastic part, or at least partly it can be plastics, frames, cell holders, thermal management components, and also connectors, for example. These are then plastic fields. We always combine this or connect this to the request from the market, means also here the sustainability, lightweight, flame retardancy, shielding effects or thermal conductivity. And by this also here a portfolio behind, means there are then also always grades already behind fitting in this direction. What I like to mention on this slide is there's a lot of discussion regarding flame retardancy and UL94V0 performance. And we participated in a big program regarding the battery casing, battery housings. And it came out that there's not really a request at the moment, or a specification, better to say, to use an UL94V0 material. There's in some cases for sure from OEMs and system suppliers the wish to use it. The reason is for this, that also here the fire protection is supported. This is more or less the most important regulation. There are different regulations in place, and all of them are pointing out that the passenger have to get out safe. Means you have to get also a 5 minutes escape time. In some cases, they get also here up to 10 minutes with a safety margin. But it's the most important, and the UL94V0 is mainly there to support also this, but not really here. It's not a specification from the car manufacturers. For DC-DC converters, the status quo is similar to what we saw for the battery casings. There's a lot of steel, aluminum is therein, means also parts of plastics, what we see for the connectors and also inner parts, but mainly it's out of steel and aluminum, means also here a nice potential in future to get here also plastics in. The applications are more or less also similar. It moves in the direction of a housing, also frames, structural parts, and in this case also cooling plates and connectors are then also potential application fields for plastics. Also here connecting this also with the requirements from the market regarding sustainability, lightweight, flame retardancy, shielding, and thermal conductivity. And also here the same, in some cases OEMs and system suppliers, they ask for a new UL94V0 material, but there's not a clear need and push, also specification behind using such a flame retardancy. More important is electromagnetic shielding, which is then also here required. Thermal conductivity on a lot of applications is there required. Water glycal resistance, if there's also a water-cooled system behind, is really important. And what we see more and more is electro-friendly material, means that there's no a negative impact on electrocorrosion. For the charger inlets, it's a bit different. The status quo is already plastics, means all of them are out of polyamide, flame retardant, glass fiber filled. Means this is already there, this is standard, and these are also examples from existing new car models from 2020 and 2022 from Asia and from Europe. Means all of them are looking the same, and also the requirements and the plastic behind is more or less the same what you see here. But in future there are for sure then also some additional requirements coming, and the requirements itself will stay like it is, as said. But there will be then also a push to use also here sustainable solutions, means recycled or bio-based materials will be more and more requested for this application field, and also illuminated areas, means there's an illuminated ring or symbols are there. And this is then also here a nice connect for us for our lighting portfolio, means our ALCOM portfolio. And if this is moving to sustainable solutions, then also our Altec Eco grades are already there and existing. Let's have a look on the under the hood situation for a full electric, means a BEV, versus also here a combustion engine. And the under the hood temperature for a combustion engine is roughly 150 degrees. Most of the OEM set this temperature as a standard under the hood temperature. For a full electric, this will be for sure below 100 degrees. Then the operating temperature for plastic parts is for sure different per application. But for a combustion engine and, for example, for a hot charge air duct, this is in the range of 210 degrees. sometimes less, sometimes a little bit also here on a higher level, but around this 210. For a full electric car, the operating temperature for plastic parts under the hood will be up to 100 degrees, not more. The cooling temperatures for plastics for a combustion engine is in the range of 120 degrees. For some OEMs, there are tests with 135 degrees, means also here at a higher level. For a full electric, this will be in the range of 60 to 90 degrees, means which is really clear that the temperatures are clearly going down for the full electric cars, and other requirements are then also stepping in, like flame retardancy, electro-friendly, and also shielding effects, what you need also in some application areas. And by this, then also the polymer will change. Means under the hood at the moment, we see a lot of polyamides, also PPAs are there. For a full electric car, this will move in the direction to PPs, then also PC, ABS. And then for sure, if there's a polyamide, it is more polyamide 6. There's not a real need to think in the direction of polyamide 6.6. Then for European standards for the charging, it will be also more or less the same. Also here for Europe, there is not really a need and also not a requirement to have also here a UL94 VCO material in place for wall boxes, for example, charging stations. There are then also specifications, but they are then connecting to, for example, the GWFI, to impact or other tests related to the wall boxes. And for connectors, it's the same. Also, there are tests in place. Then there's, for example, a ball pressure test, and also heat aging tests are there important, but not really the UL test. No? And if we now connect this to our material portfolio for the EV charging infrastructure, there's the Altech, and for Altech Eco, we have then also here our Prime version and also the Altech Eco materials. And this then connecting to mounting brackets, for example, housings, electrical components, connectors. And we can always connect this also here to different polymers, means there can be a polyamide, a PC, ABS, PC ASA. It depends what our customer needs, and we do all the customization in this direction. If there isn't for the charging station also a lighting effect, and most of them, they have lighting effects, then for the display, for design elements, for symbols, there's an also here a lighting portfolio supporting this. And also here we do all the customization to fit also here the customer requirements, and also to get also our material specified in this direction. And there are also more, means if there's a special request on shielding, or could be then also here higher strengths connected with flame retardant materials, there's also an ALCOM portfolio existing, but also our strength is here the customization. Then let's have a look on the e-mobility portfolio, and I like to highlight on each slide one grade. Means for e-mobility, we already have a portfolio. And for eco materials, for example, on the first lines, you can see the polyamide 6 and 6.6 polyamides, glass fiber filled materials. And these are special developed for fitting an OEM requirement, and also here to get on the panel for an OEM, means supporting what we saw in the beginning of the presentation. All the CO2 reduction is really here, also here, moving this direction that our OEMs ask and also request this. And this was more or less here also developing a grade in this direction. But now we can also modify this, customize this for other customers in a different way if they have also different requirements connected to these materials. Then for Altech, I like to highlight the PP flame retardant. Also, this is a material was especially developed here for an OEM for big new platform, and connected here to a junction box application. And this can be also used in future for different other applications, and also modified if there's a need in this direction. And on the last slide here for the e-mobility portfolio, this then also for ALCOM, I like to highlight that we developed here an ALCOM HP. The HP was especially developed here for battery ventilation system. Also here together with an OEM, they did a lot of tests regarding here also climate tests and so on. And this material can be then also used in different other applications, but for sure then also modified if there's then also here a customer request and requirement regarding here customization. Means for all the different product lines, we have then also here more or less like a menu, what you can also check and see. If you have a special requirement and also here a need, then you can always connect with a portfolio behind, and MOCOM or ALBIS people that can help you to select and also the right material. Or if this is not existing, we can for sure do the customization there for you. Means to sum it up, we do customization, this is our passion, and we do this day by day. We do this also here in a quite new market, means there are, what you saw already, there's a lot of potential in to get also plastics in the e-mobility. And by this, there is really a huge customization need in future. And we do this for our prime materials, but also here for our eco materials. And by the fact that our customers are global, we also support our customers for sure globally for all their application work. Thanks a lot for listening, and I'm open for your questions.
Thank you, Kurt. Thank you for this talk. Very interesting. And let me welcome Thies Vrobel, because as I said, Kurt can't take your questions here, but we have Thies Vrobel here, who, as I said earlier, is part of Kurt's team. So we get first-hand answers here. Now, I think we have 3 questions that came in already, but the audience, let them come in. There's more space for more of your questions. And I hope I'll have Thies here on my screen in a minute. That's us here. Hello, Thies. I think you're calling from Poland, so thank you for being here with us.
Yes, I'm on a business trip. Yes, correct.
That's great. Great having you here. Actually, Kurt's talk, there were a lot of interesting questions, and I'll just shout one at you, if that's okay for you, Thies.
Yes,
question
please.
is, perfect. The question is, I wonder if there is no need for high CTI for charging applications. Now, if you could, in your answer, also say what CTI stands for, that would probably help a lot of audience as well.
Okay, yes, the CTI is a comparative tracking index, and if it's higher, you can have contacts more close together. So in a connector, for example, and then of course there is a need for high CTI. For example, this is a reason we developed PPS with, it's called TDOR HTR with CTI of 600. Of course, we see necessary for high CTI. We have also developed Altech PA66 GF flame retardant grades with also high CTI.
That's great, thank you. And the second question is, how high can the percentage of recycled material be with Altech Eco? So it's the German word Rezyklatgehalt. So how high can the percentage be?
Okay, good question. First of all, the typical OEM requirements are 20% or higher. Sometimes also application related. It could be up to 100% polymer recycled content. So we have compounds from, let's say, 20 to up to 100% recycled polymer content in the compound.
Well, thank you. And the third question is that the CO2 savings for Altech PA Eco, they are very impressive. I think we saw that on slide 13, I think it was. Could you say a few words about where the major CO2 savings actually come from?
Yeah. For Altech Eco, we mainly talk about mechanical recycled polymer, and compared to polymerization, and also for taking the raw materials, pre-treating the raw materials, and then the polymerization process, it needs a lot of energy, and compared to our mechanical recycling. This is the reason you have for the nylon, for example, 6 times less energy consumption for the recycling materials, and for the polypropylene you have seen around 2 times less.
Great, thanks. I'll just be cheeky because I have a question on my own. Because you said in the presentation that it's actually fewer parts per car that are going to be introduced. But it's the plastic. If I get it right, it's the plastics that will change. They will be more technical as they are now. So plastics as they're being used today and plastics as they will be used with e-mobility. How do they differentiate?
Let's say not less or more technical, because it's other requirements. We got other specifications, requirements from the OEMs. It's more flame retardant, less high heat stability, for example. This is what is changing. So the plastic itself, the requirements on the plastic are changing. From the high heat stabilization to more flame retardant.
Thank you. So lots of things to invent and lots of changes to cope with. Thanks so much, Thies, for being with us. That really helped us.
You're welcome.
Thank you. And thank you also, audience, for your questions. Thank you. Now, we all have deserved a little break, and we will have that break for now. Take a break, breathe, get some fresh air. So make sure you don't watch the screen. Have a break, and we will meet here again at 3:05. So that's 15:05 that we will meet here again. Stay with us and have a great break. See you later. Hello and welcome back, everybody. I hope you had a good break. I know that very many didn't have a break. If you are like me, you just check the emails in the breaks and never do anything else. If you're one of those, take your eyes and put them away from the screen. Find a tree, look at a tree for a second, and only then come back, because we need that break. We have so much coming up now. So let us carry on, and Horst and Stefan have joined me here for a little recap on what we heard so far, just for a few minutes, and then thank you for those of you who sent in a few questions for Stefan, so we will address them afterwards as well. So let us start. Horst and Stefan, thank you for joining me again. And what has struck you most in the presentations that we've heard so far? And I'll start with Horst.
Yeah, well, it's fascinating to see how the industry is reacting, how we keep improving processability, and that many things are about safety and the other properties that keep changing, and where there's a strong demand about the flame retardancy, the electric insulation, mechanical properties, all over, where it's exciting to see that plastic is required to maintain that sustainability, playing a key part in this evolution.
Stefan?
Well, for me, I'm not a plastic expert, to be honest.
Not yet.
But for me, it's fascinating to see how research is now coming into battery technologies and what it means for the future of the business and the markets. From my personal background, I think the next battery technology that is coming up will be the solid-state battery. So this will bring completely new requirements and technical adjustments, I guess. So we are just at the beginning of these industries, and of these proliferation of the technology. We are discussing, for example, in China and in Korea, how battery swapping stations, not only for bikes and for mopeds, but also for cars, might be part of the overall mobility system. And this brings new adjustments for plastics as well. So there's a vast opportunity for you folks, in terms of where to go with what kind of product requirements and adjustments for the future to come.
So lots of places to go. And if we go back to Stefan's world that you've drawn for us in your keynote, where does all this fit in? What we heard about the heat retardant material and all these things, where do they come into Stefan's world?
Everywhere, I guess, everywhere. In all the mobility schemes. It's not only car adjustments that you have to incorporate, it's adjustments for all these technologies. Yes, we have these issues at the moment, with all kinds of technology. And you need to have monitoring schemes, you need to have research schemes, you need to have technical standardization schemes to come into place in this industry from now on, at latest.
From now on, and then there's continuous innovation, I guess.
Yes.
Certainly.
Mm-hmm.
Yep.
Yes. Right. Okay, and then what else can we say? Which solutions have struck you most? Which solutions that we just heard about in mobilities in the talks? Maybe you?
Yeah, on one side, it was good to see that LANXESS has improved the processability of a material, halogen-free. And it was good to see from MOCOM that the degree of customization will continue, where a compounder has this flexibility to play with all of the base polymers and individualize this for smaller demands.
Mm-hmm. So customization, that also fits into your world.
Yeah, definitely.
Perfect.
And it fits into the sustainability world as well, How to make processes more sustainable in this sense. So, perfect.
Perfect. So let's go back to your world then and answer these three questions that came in. And I will start with the first. That was the issue with the mobility or there is an issue with e-mobility, and it comes up with their own, so everybody comes up with their own apps and their own software, making consumer life complex. Are there initiatives for standardization?
Well, it's a nuisance from a customer standpoint, that's for sure. What we see a consolidation in the players' markets from now on. So scooter providers are taking over bike providers and integrating into a bigger app and a super app. We see super app applications coming up with FreeNow, for example, which integrates 5, 6, 7 other players. There is no political initiative for standardization at the moment, which is a problem. We have in Germany alone more than 150 public transportation agencies. Yeah. So you need to negotiate these with every single player, which is hard, to say it at least.
And consequently, I think we will continue to be faced with this huge complexity.
Yes.
So there is limited standardization, if at all.
Yes.
And that will also mean for plastics that you will have the full complexity all over the portfolio.
Definitely, that's right, yes.
Tailor-made solutions.
Yes, definitely.
That's quite a challenge there. So the next question, if we can go on to the next question, here's my cue. No, that's another one. Here we go. Munich. You mentioned the autonomous cars in Munich. Will they work like buses in fixed lanes, and do they have a total radius? They can't go any further. And is the governmental admission already given? And when is the starting date? Somebody's very, very afraid here, I think.
I guess the starting date is autumn this year. No, there are no fixed lines. Yeah, these are robocabs just driving in our streets with all the other players, yeah, with private cars, with public transportation, with cyclists and pedestrians. This is where it happens. Yeah, there is a safety driver on board, but it will be an on-demand solution. So if you need it, you give them a call by smartphone with a single app, of course. Yes, but it is, and the city of Munich approved it for the whole city area, and it. We are, by the way, we are in Germany, by far the most progressive player with regard to the regulative environment for autonomous cars. Far, far ahead of the United States, far, far ahead of China. France is doing pretty good in this respect as well, but Germany is leading the regulatory environment for autonomous cars, which is astonishing, to be honest. I wasn't aware of this until recently. So the game field, yeah, it is set, it's here. So let's play it.
Let's play it, great. And then one last question. How do you see the intercity mobility and suburban commuting? Yeah, suburban commuting for the future?
Well, these are two very contrasting issues. Intercity mobility, well, there's huge a growth plan from German Rail for intercity mobility, and they are improving stations, they are improving the net, they are improving the service, and they are strongly benefiting, obviously, from flight shame, so not flying anymore. I'm not sure whether you're aware of what is happening in France. You are not allowed to service an airline, a flight route, between cities that can be serviced by TGV within 2 hours. So everything what is in a context of 2 hours for the TGV is not allowed for aviation anymore. And this is a very radical approach to fight climate change. Yeah, and suburb commuting, yes, we see a lot of approaches how to get more flexible solutions. Yeah, in Germany we have about 80% of the people living in a surrounding of 800 meters to a bus stop or a public transportation stop. But it's not important when there's only once in the morning and once in the evening a stop stops by. Yeah, this is no mobility. So we need to get more flexible. And there are new, well, ride pooling schemes, yeah, where you bring more people together in a small van to bring them to the next station. And these are examples of very low penetration at the moment, but these are future business models for cities and suburbs.
Great. Thanks so much. Thanks both of you for being here with me.
You're welcome.
And we can now move on to SOLVAY. So many things are going to change, as we just learned. Let's move on to SOLVAY, because they have a very clear view of the future, because they called their talk, it's reflected in their title. It claims that the future is electrified, lightweight, and sustainable. So on to Nicolas Batailley. Good to see you, Nicolas, here. Hello from Hamburg. Hello. And he's the e-mobility marketing manager at EMEA SOLVAY. And on to you, Nicolas.
Good afternoon. Thanks a lot for the introduction. Do you hear me well?
We can hear you well, yeah.
Perfect. So let's start. Do you see my screen?
That as well.
It's coming. Okay. So thanks a lot for the introduction. So today, I'm going to start a speech with a short introduction about SOLVAY, a couple of slides, not more. Then I will explain why e-mobility is a hot topic for the polymer industry. We saw that e-mobility is a hot topic for the total industry, for people, but for the polymer industry, it's even more valid. Then I will explain why our future is electrified, lightweight, and sustainable, and provide some examples. And then I will be more than happy, more than delighted to answer to the question if there is some. So, SOLVAY. SOLVAY is a chemical company, a Belgian one. Our headquarters is located in Brussels. We do have 21,000 employees working in 98 industrial sites and in 63 countries. Last year, we have generated a turnover of roughly 10 billion euros and an EBITDA of roughly 2.4 billion euros. The interesting thing is that 53% of our sales are generated by sustainable solutions developed by our 21 major research and innovation centers. And the last figure I wanted to share with you is that our market portfolio has got a market leader position between number 1 and number 3 for 90% of our solutions. So, talking about portfolio, SOLVAY has got the broadest polymer portfolio among all the chemical industry. I'm not going to enter into the details today. It will be super long, it will be super boring for you, and maybe a bit for me as well. But just be aware that we have structured the portfolio with 3 pillars. The first one is amorphous polymers, where you find the sulfone and the PAI. Then we do have semi-crystalline with LCP, PPA, PPS, fluoropolymer, ultrapolymer. And then we do have, as a third pillar, we do have elastomer and fluid. So that was for the introduction. Now let's enter into the topic. So e-mobility, really a hot topic for the polymer industry. You probably already saw this slide or this graph. Here we disclose basically the CO2 emission constraints applied to the car makers year by year. If we want to focus on Europe, so the blue curve, you can see that in year 2000, the constraint was 175 grams of CO2. Now, in 2021, 2022, we are at 95 grams of CO2 per kilometer applied to a fleet produced by a car maker. European Union want to go further. European Union defined already a target for 2030, which is 59 grams of CO2. And they even think about to go further and apply a target of 47.5 grams of CO2 per kilometer. Those targets cannot be achieved now without modifying things. So first, car makers need to continue the job of lightweighting. This is mandatory. They cannot escape that. They need to go further. They need to go faster in lightweighting. And second, they need to electrify. And without electrification, those targets cannot be achieved. The first consequence is the investment. 350 billion euros will be invested by global OEM in electrification by the end of the decade. So in the next 7-8 years. 350 billion euros is just massive. It's just unbelievable. the result of that is here. Here you can see projections of car production from, let's say, 2017, so it's no production there, up to 2028. Obviously, those figures are wrong, meaning they are not true. We are talking about projection, but it gives a trend. In gray, you do have pure internal combustion engine. With color, we have identified electrified vehicle. When I said electrified vehicle, here we are talking about mild hybrid, full hybrid, plug-in hybrid, and battery vehicle. And you can see that by 2028, electrified vehicles should basically achieve 44–45% of market share globally on a worldwide base. And by 2030, electrified vehicles should reach half of the market. Just to give you a figure released by the ACEA Association 2 days ago, in Europe, in Q1 2022, electrified vehicles already achieved 44% in Europe. So the trend is there, things are going in that direction, and meaning this is evident. Okay. So you understand, based on that, that our future, the polymer industry future, is electrified, lightweight, and sustainable. So let's dig a bit deeper in those three topics, in those three concepts. Electrification, we can spend hours. It's a passionate topic. We can spend hours or even days to talk about electrification. Here I've decided to share one example, which I think is quite representative of what's going on. And this example is the PCB connectors, so printed circuit board connectors. So let me explain. A PCB connector's got some technical requirements, meaning it needs to be compatible with surface mount technology, and I will explain that just after. It needs to be allergen-free to avoid electrocorrosion. It needs to have a low water uptake to first avoid corrosion, and second, guarantee a certain level of dimensional stability. You need to resist creep and fatigue, to have eventually thin wall thickness, or ideally thin wall thickness, and I will also explain why, and potentially need to be chemical resistant. The obvious answer to these requirements are PPA, and in our case it's a model PPA and a model PPA BIOS. Go to the click here, sorry. Before to enter into the material detail, let me explain or dig a bit deeper into two concepts. First, the surface mount technology, SMT. When car makers, when customer wants to assemble electronic components on a PCB, in most of the cases, they use a technology which is so-called reflow soldering. Reflow soldering allows to work with a very short cycle time. But this technology operates at high temperature, between 260 and 200 degrees C. Time to time, it can go up to 305 degrees C during a couple of minutes. So it's quite an important temperature. And this high temperature can generate some blistering, some bubbles at the surface of the plastic component. This is not acceptable, and this is going to generate some quality issues. To avoid that, you need to have the proper material selection to be sure that your material is compatible with the different surface mount technologies existing today. The second concept, important in electronics, for car electronics, is the size reduction. Car makers, as already mentioned, assemble electronics on a PCB, some chips, and they also assemble connectors. If you are able to reduce the size of the connector on the PCB, you can increase the available space to add more connectors and to increase what I would call the, let's say, electronic density of the PCBs. And if you select the right material, you can reduce the size of the connector to 50%, meaning you can divide by 2 the size of the connector. And when you do that, obviously, you generate free space to add more electronic components and have a more compact electronic and power electronics. So, based on that, why a model PPA? Why PPA? First, a model PPA has got a heat deflection temperature, so HDT, up to 310 degrees C. The continuous use temperature is 185 degrees C. And the TG, the glass transition temperature, goes up to 165 degrees C. And here you can understand that thanks to these characteristics, PPA is a material of choice for surface mount technology. In addition, PPA offers low water uptake, 0.2%, around. A high strength and stiffness even at temperature, an excellent retention of mechanical properties, and the material is available with electro-friendly package, so to avoid electrocorrosion, and if needed, with flame retardant package. So a model PPA is clearly compatible with different reflow technology, reflow soldering technologies, like infrared or vapor phase. Time to time, people ask me, okay, PPA is fine, but why not 6.6? Polyamide 6.6 is used for, already used for connectors. It's true, Polyamide 6.6 is a good material, but PPA offers higher properties. If we have a look at the heat deflection temperature, so HDT, and melting temperature, here on the graph, you can see that PPA's got higher properties. But let's go a bit further. More important, tensile strength. PPA start higher than PA66. Here we're talking about 225 megapascal, and more at dry azimuthid. And more important, keep these properties, this tensile strength, even when there is a humid environment. Here, for example, you can see a 50% of relative humidity. And when there is 50% relative humidity, the material PPA retains roughly 10% of its tensile strength. In comparison, Polyamide 6.6 start lower, 185 megapascal, and lose 2/3, 60%, 2/3 of its tensile strength when exposed to humidity. It is also true for flexural modulus. A model PPA flexural modulus, 11 gigapascal, with 50% relative humidity, flexural modulus remains stable. PA66 will start at 9 gigapascal and will lose roughly 1/3 of its flexural modulus. Clearly, a model PPA offers higher performances to improve reliability of connectors, of automotive connectors. Second concept, I told you, the polymer, future of polymer industry is electrified, lightweight, and sustainable. So here we are in the lightweight aspect. Lightweight is not new, meaning lightweight activity exists almost since the car industry exists. When we talk about electrification, when we talk about hybrid vehicle, it's even more important. When you decrease the weight of a hybrid vehicle, when the car operates with internal combustion engine, with gasoline energy, you can reduce the CO2 emission. When the hybrid car work with electricity, then you can increase the range of the car. So lightweighting of a hybrid vehicle, and also for an EV, is super important. So here, let's go into the detail of one example, which is a battery casing. I'm talking about a 48-volt battery casing, battery protection. To give you an idea, because on the slide you cannot really see, we're talking about a box, a housing which got the size of shoebox, just to give you a rough idea. The purpose, the aim of this battery box is first to offer a physical barrier that prevents damages to battery cells in terms of collision situation, to insulate the battery cells from temperature extremes, negative or positive, to keep contaminants out, and to provide a safety barrier against voltage spike, fire, thermal runaway, etc. How it works? It's rather simple. Here on the first bubble, you have the cell. So the cell module, you do have battery cells encapsulated or blocked together with components which are made with stamped steel. This cell module is fixed under this battery housing lid or this cover. And the entire system is fixed, immersed in the box and fixed in the box, in the battery housing. So if you want to lightweight the system, to reduce the weight of the system, obviously, the first idea you have is metal to plastic approach. So let's go into the details. Here you have the system assembly. So the cover, the lid, and the housing. The lid is made with aluminum. The weight is between 800 and 900 grams. The box is made with aluminum as well and weight 2.3 kilograms. This battery housing and battery lid is used or was used by one of our German customers. I will not disclose the name, but all the story happened in Germany. So basically 2.3 grams plus 800, 900 grams. So we are talking about 3.2, 3.3 kg in total. The first activity action we decided with our customer was to work on the housing itself. So 2.3 kg, we redesigned the battery housing using, let's say, the most advanced tooling existing today. We adapt the design, we take into consideration PPA characteristics, and we were able to reduce the weight by 500 grams, half a kilo. So from 2.3 kg, we jumped to 1.8 kg. This without any compromise in terms of safety. If you have a look here on the face, we have a ribbing system, kind of honeycomb system, I would say. This increases the stiffness of the box and allow to avoid any contact between the box and the battery cells when there is a collision. Okay, so 500 gram saving, 20%, to make a long story short, without any compromise with safety. The second step, second activity, was to work on the lid, on the cover itself. So remember, we do have the battery cells encapsulated, blocked together with this funny metal part, and everything is fixed on the battery lid, which is in aluminum. So we do have 5 parts in total. If you want to reduce the weight, the first thing is to substitute the lid, the aluminum lid, by a plastic one. It works. It's quite easy, it works. But you still have 5 parts. So with our customer, jointly, we have decided to go further and to use the design flexibility offered by plastic to integrate function and to reduce complexity. And here you can see on this graph, we succeed to go from 5 parts to 2 parts. Okay, and this has been achieved. The next step we are working on currently is to discuss with our customers and to reduce again and achieve only 1 part. So from 5 parts to jump to 1 part. And the result is obvious, meaning you do have a process simplification, you do have a reduction of the number of components, you do have a reduction of assembly operation, and obviously you do have a reduction of weight. Now, the important question, one of the important questions is how much? How much money? The system in aluminum costs $30, $30. With the polymer redesign, we achieve to decrease by €6 to go to €24 per part. So from €30, 24. So to summarize on this activity, lightweighting activities on battery housing, so 48-volt hybrid battery housing, we were able to achieve a weight saving of between 15 to 20%. A cost saving between 20 to 25%. No compromise of safety, and this is super important, meaning there was no negotiation about that. It was not possible to discuss about that. We need to achieve the same level of safety. We were able to integrate maximum function in order to reduce manufacturing steps and, again, drive to sustainability. And this brings me to the third chapter, to the third concept, which is sustainability. Sustainability means a lot of things. We can talk about recyclability, we can talk about cradle-to-gate activity, we can talk about several things. I decided today to focus on bio-based polymer. Just let's start with a little history. In the 90s, Solvay was the first company to introduce PPA to the market. 30 years later, we launched our new Amodel BIOS. So, what is Amodel BIOS? Amodel BIOS is a bio-based long-chain PPA. Bio-based long-chain PPA. The material, the grade, is partially biosourced. So it offers a lower GWP, global warming potential, compared to a standard PPA. The bio-based resin comes from non-food competing feedstock, and this is super important, meaning you do not have to choose between feeding the planet or producing polymers. You can do both. The resin is produced with 100% renewable electricity. 100%. Here I'm talking about solar energy. This polymer offers the highest TG, 135 degrees C, among all the currently available bio-based PPA on the market, 135 degrees. Thanks to its long chain structure, these products got a lower moisture absorption compared to a standard PPA. We offer higher elongation and higher wet light strength. An excellent surface finish, colorability, and this could be super important for example, connectors. Because of the long chain structure, the dimensional stability, the chemical resistance is higher, even higher than a standard PPA. And the material is available with two packages, electro-friendly to avoid corrosion, or flame retardant, so HFFR stands for halogen-free flame retardant, when it is needed. I was talking about the GWP. Amodel PPA is already the best in class when it comes to GWP. When you compare with PA66, PA60, or even a PPA bio-based polymer available on the market, Amodel, our standard Amodel, is already the best in class. Now, with Amodel BIOS, by integrating this bio-based resin, we were able to go further and to reduce the GWP by 14% compared to an equivalent Amodel grade in our portfolio. So today, Amodel BIOS is the best in class in terms of GWP for the market. In order to answer to the most important unmet needs of e-mobility today, 4 products are available. 1 electro-friendly grade, so-called AE for connectors, data connectors. 1 FR grade, flame retardant grade, so HFFR, halogen-free flame retardant for electric application, and 1 so-called structural grade for cooling application. Here we're talking about injection molding, so cooling connectors, for example. We are not talking about extrusion, so we are not talking about cooling line. It's really cooling application, structural part. So, based on that, we can say that Amodel BIOS is a perfect material for all the surface mount devices, thanks to its performances in terms of TG, for connectors, for fluid connectors, and for all circuit breaker switches, and basically all electric equipment you can find in a car. When we compare Amodel BIOS with a standard PPA, basically Amodel BIOS offers better properties on all the assessments: moisture, tensile, wet light retention, HZT for electro-friendly, for structural grade, and for flame retardant. So basically Amodel BIOS does a better job than a standard PPA. So here comes my last slide, the conclusion. E-mobility, you understood that e-mobility is inevitable. You cannot escape to e-mobility. Electrification offers huge opportunities for plastic industry. But, and there is a big but, customer needs are changing, and the material of tomorrow are not the material we used to sell yesterday and the one we sell today. Thank you, that's the last slide, and now I'm super happy to answer to any question you may have.
Thank you, Nicolas. Am I on? Yes, I'm here. Hi, Nicolas. Thanks for your talk. That was very, very inspiring. And let me remind you, dear audience, that On the right of your screen, there is the question and answers tool, the questions tool, most of all. So drop in your questions and I will forward them here. And Nicolas, we have a few questions here. So one is that during your speech, you talked about the printed circuit board connectors, the PCB. And the person who asks also said there's data connectors as well. And is that a growing market?
Yes. Basically, there is there is a lot of echo. When we talk about specialty polymers, there is two kinds of connectors that we can address. PCB connectors, data connectors. Requirements are a bit different. But clearly, that's super important for specialty polymers, and a model can clearly cover both connectors and both markets. Yes.
That's great. And here's a question, one question regarding the metal replacement aluminium housing. Oh, sorry, can you go backwards? My question is gone. Perfect. No. Okay, I think that was here. No, sorry for that.
No problem.
Metal replacement. Aluminium housing offers EMI shielding. Are there possibilities to implement the shielding properties in plastics?
Yes. So here we need 2 hours to discuss that topic, if you have time. If not, I will try to make it brief. Today you do have existing EMI solution on the market. But when we talk about this kind of casing, we need to be, in most of the case, flame retardant, EMI shielded, stiff for a safety reason, obviously, and in most of the case, resistant to chemical aggressions. Today, there is no product available on the market able to cover these 4 main requirements. Okay, but life is changing, and in the coming weeks, I would say, Solvay will be more than happy to share with you new development, new material, EMI shielding, flame retardant, water glycol stabilized, super stiff.
Thank you. And one more question. You explained that the A model BIOS is the best in class in terms of global warming potential, GWP you called it. However, do you plan to go any further than that?
Yes. A model BIOS was the first step. Okay, so we do have 22% of bio-based material because the idea was to keep a high level of technical performances. So now we are really comfortable with this material. We have decided to go further in the bio-based content, and there is no limit. The only one limit is 100%, you know, and clearly that's the target. So clearly here we want to go in that direction. In addition, I told you the resin is produced with 100% renewable electricity. Now we are applying this method also for the compounding. So we are going to use renewable electricity for the compounding. So we can definitively go much further in the GWP reduction.
Okay, thank you. There was one more question about the temperature. Here we go. Yes, you mentioned in your speech that A model PPA has a glass transition temperature, I think that's what you call TG, up to 165 degrees Celsius, while the typical TG for a PPA is between 110 and 135 degrees Celsius. Can you explain?
Yes. Because of the reduced time, it was mandatory to shorten the story. We have developed last year, in addition to a model BIOS, a new PPA, so-called a model Supreme. And a model Supreme has got a specific chemistry and is able to offer this TG of 165 degrees C. So you're right. Traditional PPAs got a TG between 110 and 135 degrees, but since 1 year now, if you knock on the door of Solvay, you can access to PPA with a TG of 165 degrees C. And this clearly open new market possibilities when we talk about busbar, when we talk about electrification, when we talk about sensors in the power electronics or in the e-motor. So this high TG, 165 degrees C, is clearly key for your new development.
Okay, thank you. And we can squeeze the last question in as well, which says, how much, can you go backwards, please? I can't read the question. No, it was the moisture one. Here we go. How much is the moisture uptake when in contact with a cooling agent like glycol, and how does it affect mechanical properties?
So I'm not sure if we are talking about a model BIOS water uptake compared to a PPS.
Yeah.
Okay, so basically a PPS got a 0.2 water uptake. Okay, a model BIOS reduce the water uptake by, if my rate is good, 40%. So we are around 1.1, 1.2%, 0.1, sorry, 0.12% of water uptake. So 40% less, which means that we less impact the mechanical properties of the material after aging in water glycol, whatever the temperature is.
That's great. Thank you. Thanks a lot for answering all these questions as well. Thanks so much for being with us, Nicolas. Take care and see you next time then. Bye-bye.
Thank you. My pleasure. Bye-bye.
Bye. So our next talk then is from BASF, and it's a talk that involves also a demo presentation of the app Molded. The presentation bears the title Digital Simulation Support, One Step Ahead in E-Mobility, and I'm very delighted. I already have him here to see Christian Eigl on my screen here. Christian is with BASF and product owner of the simulation app Molded. Now, in order for everything to run smooth and sound, Christopher has already recorded his talk and also incorporated the simulation demonstration. So everything is fine then. So we'll watch the video, and then we have Christian here, and he will take your questions. So we can start the video then.
Welcome to this presentation about Molded, a web-based simulation tool. My name is Christian Eigl, and I am the application owner of this app. But before we go into detail about the app, I just want to talk about why we have developed Molded. We believe that simulation should be made accessible to a wider user group. Not only the CAE engineers, but also the CAD designers should have access to simulation. We also believe that if you take into account material and processing know-how very early in the design phase, that you will be able to build better products. So what is Molded? Molded is a web-based design for manufacturing simulation tool for injection molded parts. It is the first app of our newly Ultrasim web offerings, which gives you access to Ultrasim simulation technology at very early stages of the part development. It has built in our material expertise, and it gives you a first glance at the producibility of your part within seconds. Here you can see on the left side a preview of the app showing you a filling analysis. It shows you how the melt is flowing through the cavity. Of course, you have different visualizations, but we will go into detail later in the live demo of the app. For now, I just want to show you how easy it is to use Molded. It is a simple 3-step process. You first upload a geometry. You can upload an STP or an STL file. You choose a material, and then you hit the Start Analysis button. After that, you can investigate on your results, and you're also able to make adjustments in parameters, for instance, change the material or change the injection location, and you can also share the results with your colleagues. What is then the difference to existing simulation solutions? Well, here we see a part development process. From left, the product idea, to the very right, the assembly of the part, and in between we have several steps, for instance, the engineering and the part design step, prototyping, etc. And conventional solutions so far, they are more allocated towards the engineering, for instance, our Ultrasim services or a mold flow analysis. Molded, however, is more allocated towards the part design. So that way, you will have a very early problem detection, which will lead to fewer changes in later stages, which are very costly. Of course, also a differentiator is the speed of the results. You will get the results within seconds. This will lead to shorter iteration cycles between part design and engineering. And therefore, you will have some potential for cost and time savings through this error detection and the shorter iteration cycles. Also, we have kept molded very intuitive and easy to use for a wider use case. Molded gives you a rough approximation to check your design for major issues and is not a substitute for subsequent simulations. But this is really not the goal. The goal of Molded is to increase the information exchange between the stakeholders of the part development process, for instance, the rheological engineering with the mechanical engineering and the part designs, and therefore accelerate the decision-making process. So who do we see as potential users? We see the CAD designer who can use Molded to get quick feedback on the producibility of their part designs. We also see the CAE engineers who can use Molded to give feedback to the CAD designers, getting involved into the part design process more early. And we see the project manager as potential user who can use Molded to get a quick overview on the progress of his projects and to communicate with internal and external stakeholders. Of course, we can think of many more user groups and use cases. And now I want to switch over to a live demo of the app. Here you see the project's dashboard of the app Molded. You can decide to create a new project, or you can go into an already existing project. If you create a new project, then it is the simple 3 steps process as I have described on the slides previously. You upload an STL or STP file. After that, you choose a material and then you hit the Start Analysis button. I will not do that because I have already prepared a project for this purpose. I have uploaded a part design of a bus bar holder and I have chosen the material Ultra Dur B 4330 with a glass fiber content of 15%. And here we can see now the part design. I have now the opportunity to check out the part design and check out some visualizations, for instance, the thickness of the part. And here we can already see that there are some red areas here, very red, very thick areas of the part, which most likely will also lead to a very high cycle times because of the melt needs to cool down before demolding. With that having said, let's check out the undercuts. This visualization basically shows you whether the part can be deformed from the mold. And here we see some red areas, but due to that as a bus bar holder, the red areas should not pose any problems because this is where later actually the bus bars are. Let's switch to the filling analysis. Here we can check out the flow behavior through the part. I can just simply grab the slider and for instance here I can observe that there most likely is a weld line forming in this area. I also can check out the weld line indication. Here you can see the weld line forming with different visualization. You can also have a look at the flow length, especially interesting for longer parts. You can also check out the pressure. This is the pressure which is needed to fill the part. Here we see in the edges of the part some low pressure areas. We have also included a shear rate indication, and for glass fiber filled materials we've also added fiber orientation visualization. And maybe let's scale down the arrow size and zoom in. Here you see the red arrows. They indicate a very uniformly oriented glass fibers. And yeah, this is a very interesting visualization. If you have certain requirements on mechanical strength, for instance, then I would check out whether there are areas of uniformly or not uniformly oriented glass fibers. But now let's move over to the right side and see what information is displayed there. We have the metrics here. For instance, you get some indication on the cycle time or the pressure. We have included a guide feature that informs you about the most important results and what to do about issues you might face within the results displays. And of course, the user is also able to request support and get in contact with us. You can also choose to set a different injection location. If you have the setting to auto, it will automatically choose the geometric focus. You can also switch to manual and set up to 10 injection locations. Of course, you can also change the material choice. One feature we have not yet talked about is the change CAD. You can change this cut file, and I will do so because I've seen some issues with the thickness in certain areas of the part design, and that's why I've prepared another part design. I will upload another a step file, and we'll start the analysis. Now, this is actually the same process as if you would create a new project. You are able to upload a step file or an STL file. If you do upload a step file, then Molded will suggest a mesh for you. So Molded will do the meshing for you. This I always would do if I would do some quick changes in the part design just to get some quick and dirty results. If I want to have more precise results, then I would do the STL myself, so I have better control on the granularity of the mesh. So here we can see that Molded is already progressing in the calculation. This is a real-time calculation here. Really, the one differentiator from different apps is that Molded is really fast. It just needs some seconds and not minutes to hours to provide you with good results. While this is loading, maybe another very interesting fact is that we are hosting Molded on a German server. We have run through several internal BASF security assessments and passed them. Also, we have asked Accenture, specialists from Accenture, to hack our system, which they had not been able to do. So, Molded is a very secure system. The downside of using step, however, is that it might take some seconds longer to provide the results. But we have already gotten the results here of this calculation, and now we could go through the thickness indication and But what I really want to do is I want to change the material and compare then the versions with with different materials and design changes. So what I'm going to look for is the same material, but the high-speed version of it. So that would be also B4330 with 15% glass fiber, but the high-speed version with improved flow properties. One thing worth mentioning is that if your analysis should fail at that point, maybe because of a faulty mesh, then you would get feedback of Molded, and Molded would suggest then several steps you could take to improve the quality of the document, of the CAD file. Also, one interesting fact is that if you upload an STL file, then most likely the calculation will be faster because Molded does not have to provide the meshing. So what is the idea behind creating the different versions? One of the strengths of Molded is the comparability of the results. It is not a substitute for a mold flow analysis, but it will give you an indication on the impact of the changes you make. So whenever I would make a change to the part design, I would instantly upload the new design to Molded to get feedback on the producibility. Also, one could think of inviting his or her favorite CAE engineer to Molded to get feedback from him for further improvements. That way, your team can work in a more agile manner, reducing friction and information loss. Now we see that the version has been created. Now let's switch over to the version display and let's choose the versions which we want to compare. The first version had been the first design with the material UltraDur B4330 G3, and the second version has been the same material but with a changed design, and the third is the changed design with the high-speed version of the material. So now, while the visualization displays are still loading, let's have a look at the table below. Here we see the impact of the changes on the metrics. Of course, we have here with the second design reduced base wall thickness because of the thinner walls, which will lead also to a reduced cycle time because the part needs less time to cool down before demolding. Also, we have a reduced mass here. And what is interesting is that we have higher pressure requirements for the second part because of the thinner walls. That fact, though, could be equalized with the new material with the improved flow properties of the high-speed material compared to the second version. So that is very interesting, and I would maybe choose to load the third version and have a look at the displays again, maybe for future iterations of my part design. Also, what one could think of is inviting the CAE engineer again and discuss with him what are possible ways to maybe solve an issue I have with my part design, etc. So there you have it. This has been Molded in a nutshell. It's really about improving the process for cost and time savings. It's about the information exchange and getting people together for a more agile way of working. Now, at the end of this presentation, I just want to mention a few more things. First, ALBIS ADE staff has access to Molded and with it to BASF material and simulation expertise. They are able to support you in your part development process and maybe give you that edge against your competition. Also, we have added next to our BASF material portfolio some generic materials. though we really would recommend you to check out our materials. And finally, if you are interested in further information on e-mobility, then feel free to check out our e-mobility website. You can find the links on the profile area of this website. You can also will find a link to this virtual car tool you see on the top right, which will give you some ideas on material solutions for specific applications. With that having said, I hope you enjoyed the presentation, and now we are open for some questions.
We certainly enjoyed that. Thanks a lot, Christian, for showing us the app working and seeing these molding simulation. That was great watching them. Now we have a question that came in here, and I think you answered it in part already, but let's see. So the question is, what is the processing time of this kind of simulation as compared to the mold flow analysis? Because that one normally needs hours, and I think you said yours is much quicker, but maybe you have other differences to mold flow as well to point out to us.
Yeah, so really the difference is that molded is very task oriented. So we focus really on the very important questions you'll have at that time of the part development process. So before you're running a mold flow analysis, which will take like hours to days, even depending on the complexity of the part, molded really focuses on the step before that to increase the quality of the handoff you'll make to, for instance, the CAE engineer, the handoff you will make to the mold flow software, for instance, if you take that. So that's really one of the differentiator. Of course, because we are BASF, we consider our material data to be the most experienced. Let's say it like this, like that. So inside of molded, you will have the material data to our simulation expertise from the past decades, basically developing simulation algorithms around really the material fitting to a part design. And so this is really what we believe. We really want to emphasis on taking this material data, taking the processing know-how and the part design together very early in this process of part development to save very expensive errors at later stages, and therefore also have better, more sustainable solutions for the future parts.
Perfect, thank you. Saves time, I can understand that. Now another question is, can the system also calculate other materials like TPE? And if you could say what TPE is, that would also be very helpful.
Yeah, so so maybe let's not dive into too much into the portfolio. What I can say is that we have the BASF portfolio inside of the app. And we have generic materials. For instance, ABS would be one material, but the quality of the data is not that good because basically you will not have the choice of a broad portfolio as for BASF materials. Of course, you will have one glass fiber reinforced option for the generic material, and one not glass fiber filled option for that. So this answer is a little bit more broad, but right now we have EP materials and TPUs to put it in a broader category.
Okay, yeah, thank you. And then another question is, how secure is the application? After all, it's web-based, so how secure is it?
Yeah. So whoever has once visited BASF, one thing is quite sure, like right from the beginning, the security aspect, when you go through the gates of the Besucherzentrum at Ludwigshafen, you notice very, very quickly, okay, this is a company which has security like carved into their culture. And this is also very important for us, that this actually the priority number one when we develop is the security of the system. Of course, we don't rely on ourselves and our opinions. So what we've done is we went through several internal security assessments of BASF. Like they have very high standards of security. And we have also let us hack from an Accenture specialists team, and they were not able to break into our system. The system itself is like the parts. They are hosted at an Azure cloud, and this Azure cloud is also very secured via cybernetic services. And it is that not even the developer team has access to the customer's data. It's that secure. Besides, the customer would request access to their parts for support reasons, if they have a question, of course, and then they would sort of give us the key to their parts. So maybe to answer that.
Yeah, perfect. I think related to that, there was also one question asking what happens to my data after using the app. So will you be using it, BASF?
No, we have no interest in using your CAD data. Of course, we look at data of the usage as we want to improve the app, but this is also very transparent and written in our data privacy. But we don't have the data of a single user, so we will not look into your projects. Or just if something goes wrong or something is failing and you request support. Of course, we will have no access to primary data. As I said, we will not have access to CAD data itself. So that's also very important. And also not the core business of BASF. So we really want to support our customers and of course ALBIS in supporting their customers.
Now, supporting the customers, can I have the question that was there before? I think it jumped. Can I ask my colleague to give me the other question? Perfect. Somebody asked, if I need more support, will you also offer fulfilling warpage simulation?
Yes, of course. So you will have you will have a support area inside of Molded. You can request several types of support, and one would be, for instance, if you have questions about simulation. Molded is also it's thought to be a very quick feedback tool also in the discussion with the customer. And if you need, of course, like a more extended simulation services, then of course, our customers would have access to, for instance, Ultrasim services, doing like a full-grown warpage analysis. Yeah.
Okay.
And also, of course, ALBIS ADE staff is also able to help you in the first step.
That's great, thank you. I think we can squeeze one more in. It's about the algorithm. So the algorithm you're using, is that your own, or have you used or adapted algorithms from elsewhere?
No, this is BASF algorithms through and through, and we also have patents on the algorithm.
Okay.
Algorithms.
Perfect. Thank you so much, Christian. That was very, very good seeing it. We can really grasp it now very well. Thank you. Thanks for joining us. Bye-bye.
You're welcome.
Okay, and we can move on to the next talk then, the talk from COVESTRO. And I will be joined for this presentation by 2 and even 4 people. It's called Electrifying Mobility with Sustainable Polycarbonate-Based Material Solutions, Charging, Storing and Distributing. And this talk will be given by 2 people. It's Heliana Cárdenas from COVESTRO and Iman Fotovat, also from COVESTRO. Now Iman, and I can see him here already. Hi Iman. He has been working as EMEA Market Development Manager for Electric and Electronics with COVESTRO for the last 3 years. And Heliana works as Marketing Developer for the Battery Packaging team for the European region. Hello, both of you, and on to your talk then.
Okay, great. Thank you very much. So you can hear me well, right? Can you hear me?
We can hear you well, and we can see your presentation as well.
Perfect. Yeah. Okay. Thank you. So good afternoon. A warm welcome to everyone. my colleagues Heliana, Konstantin, and I from Engineering Plastic Division of COVESTRO are very pleased to be here today in ALBIS Tech Day on driving e-mobility solution. And we want to give you an interesting insight into the world of charging, storing, and distributing using more sustainable polycarbonate. So talking a little bit about COVESTRO. So COVESTRO is one of the leading companies in the field of plastics in the world. Last year, we had almost 16 billion euro sales, and around the globe, approximately 18,000 people are working in COVESTRO across all continents. And we have over 50 production sites globally. We serve many of the markets that you are familiar with, like automotive, electronics, appliances, and healthcare, and many more. You might recognize us as the inventor of the polycarbonate and polyurethane chemistries, formerly under the name of the Bayer Material Science. And we've been named COVESTRO for just over 5 years. Now let's go to the main topic. So we see that the automotive industry is undergoing a major transformation to become connected, autonomous, and electric. And this change from the internal combustion engine to hybrid and electric vehicles plays a major role in this transformation. This does not only affect the traditional interior and exterior design, but it also brings new application into the market, such as batteries, charging stations, and electric powertrain. Which means this would bring also new challenges for OEMs, designers, and manufacturers, which among them we can refer to safety, dimensional stability, and scalability as the major ones. Today, when we look at the internal combustion engine car, we see that the amorphous material have almost no share in the under the hood application because of the nature and intrinsic properties of these materials. For example, harsh conditions that includes mix of oils, fats, and fuels in combination with very high temperature of the combustion engine made the usage of this amorphous material like polycarbonate impossible. However, electric vehicles operate under different condition, having different temperature levels and also lower exposure to aggressive chemicals that allow amorphous materials to enter into the field of powertrain applications such as onboard chargers, sensors, or power distribution units. Now engineers have this opportunity to broaden their portfolio of different materials. New requirements of EV chargers, lithium-ion batteries, and electric powertrain can now be fulfilled by polycarbonate. So in COVESTRO, we have experience with polycarbonate since 1953 when it was invented, let's say by our former colleague, and we are offering various grades and blends based on this material. So Macrolone is the brand name of our polycarbonate, very well known in the market. Actually, in our region, everybody says Macrolone, they don't call it polycarbonate because of its unique combination of transparency, impact, and temperature resistance. For high temperature applications, we are offering APEC, which is an excellent choice for applications which you need higher temperature. It's somehow like a high heat polycarbonate. And then Biblend, which is a blend of polycarbonate with ABS and ISR, which is known for its excellent balance of temperature, low temperature toughness, and also processing behavior. And last but not least, we can also talk about Macroblend, which is a blend of polycarbonate with PBT and PET, and this semi-crystalline content where certainly it brings higher chemical resistance to the material. Now, let's talk a little bit in detail about EV chargers and how we, together with ALBIS, empower charging electric vehicles using polycarbonate. So I decided to start the topic of charging session with a case study right from the beginning because I believe it exactly shows how COVESTRO and ALBIS could support and help the companies from design to full-scale production. So here we are referring to the company EVBox, which is a European company founded almost 10 years ago when EVSE market was still in the early days. And today they are one of the leading supplier of charging stations. They installed more than 300,000 charging points worldwide, and they are increasing this number to 1 million charging points next year. Our cooperation with EVBox started right from the beginning in 2010, and ever since we are supplying them our materials for different wallbox projects, AC public charging stations, and also DC fast charger. The majority of the materials used in the housing of the EV box charging stations is macrolon in opaque, transparent, and diffusive color. And in this slide, you can see, for example, the icon and also the LV model, which the housing is made of macrolon, and it can fulfill all those requirements, which is normal between the charging station companies, like, for example, IK10, UV aging, and also flowability that can replicate the mold surfaces. Basically, our support is with these projects is not only limited to the material selection. We also come together with the molder, with the designer, with the ODM, and we talked about the materials, the part design. We see the simulation studies on mold design and analyzing the parts, especially for the IK test at room and minus temperature, and also being present during the injection trial. We make sure that the optimized settings of the tooling is being used for the production. But the question is why EVBox and other companies producing EV chargers use polycarbonate for their housing. So here we identified 4 main properties that should be considered for producing of charging station. The first one is the weathering resistance. So EV chargers, especially the ones that are located outdoor, they're exposed to a variety of weathering conditions, from direct hot sunlight to freezing snow. And in this respect, the customer needs a durable material that can use outdoor, and after weathering aging, it can retain its properties in an acceptable range. The enclosure should also be IP sealed because they should somehow protect the electrical components inside. The other important factor is the safety. One of the most used places that the charging is happening is at home. So when people come back home in the evening from the office, they park their car, they go to have dinner with their family, and then they go to sleep. And during all this time, the car is being charged. And charging stations are among the devices that draw a lot of energy from grid. And nobody wants that during the time that they are sleeping, an electric shock or failure happen, which cause, for example, burning the house or burning the cars. That is why it's very important that the safety certification by standard authorities like UL or IEC is fulfilled. And normally we recommend our customers to use flame retardant grades for the housing of the charging station. Another important factor is the impact resistance. So like any other outdoor devices, these devices are also vulnerable to vandalism. And that is why it's important that they are the housing is impact proof. And last but not least is the aesthetic design. And this is important because when we look into the market, there are many companies currently working on topic of charging stations, from startups, traditional electrical companies, automotive OEMs, and the competition is very high. And they would like to somehow differentiate their products with using CMF topics, color, material and finishes, and they would like to make it like eye-catching surfaces that people get attracted to the final product. This topic becomes even more important when it comes to automotive OEM, because they want to somehow replicate their automotive brand, and that is why the aesthetic designs is playing a major role. Here you see an overview of different IEC and UL standards for charging station and charging plugs. The requirement for the charging plug and charging station is different, and also it's different based on the region. I mean, depending on the region that you want to launch your product, the requirements are different. And in COVESTRO, we check all these standards. We make sure that we have the solution that can fulfill the requirements for these standards. Here, we want to highlight our material offering for EV chargers that can fulfill the requirements that I mentioned before. So for the design cover, as we call on this slide, there are different options of transparent material depending on the design and also the charging station. So if the transparent cover is the integral part of the housing of the charging station, then it has to fulfill requirements such as 5VA and F1 listing. If the transparent cover is just a decorative part, then we have a layer which is placed behind it, and it's somehow this part is actually protecting the internal components, and then you don't need to use, for example, flame retardant grades, and general grade, purpose grades like Macrolon 2807 would be enough. In case that we have to fulfill this 5VA F1 listing, which is also important for the housing and 1-month bracket, then F1 listing and 5VA is important, and we can offer, for example, Macrolon 6487. In other situations, there are also PCABS and PCISR grade that they also have their own advantages, and we can also offer sustainable portfolio, which later on my colleague Heliana will give further details about them. But sustainable solutions are also available for charging session. And if you are interested to get more information, our colleagues in ALBIS are aware of all these details, and they can help and support you for further information. For the charging plug, the requirements are also a bit different. Here, especially mechanical properties and weatherability are important, but also temperature resistance and flammability should be considered. There are also certain requirements on thermal resistance of the material, and that is why normally PCABS and PCISR is not used for these type of application. We are also offering low temperature impact modified polycarbonate for the housing of the charging gun, which can actually fulfill the toughness at low and minus temperature. In case, for example, chemical resistance is needed, then, for example, Macrolon FR6011 could be a solution. And to generate a good haptic impression of the charging plug using soft touch elements, we can also offer, for example, TPU materials for the parts, like the part here in orange that you can see. And this would give some kind of a decorative elements. So with that said, I would like to mention again that we in COVESTRO and also colleagues in ALBIS are available to help and support you for questions on selecting the right material and also developing the projects on charging stations. So Heliana, stage is yours.
Hello, can you hear me? Okay,
Yes.
1 second. Yes, you can hear me? Okay, good. Thank you so much, Iman, for this excellent introduction and for walking us through the charging solutions that we have at COVESTRO. Now I would like to talk to you about how we empower battery packaging for electric vehicles with our materials. So first of all, what we usually talk about when we start talking about battery packaging applications and what we bring in terms of our more sustainable polycarbonates is our value proposition. Yeah. There are diverse OEM requirements, and the market dynamics is changing quite fast. So usually we summarize this in 5 critical points that we see are valuable and important. The first one would be safety. Yeah, so our polycarbonates use non-halogen flame retardant agents that enhance the flame resistance of the material. Yeah, so without affecting any impact properties against abuse and crash for the packs. Second important point is the mass assembly efficiency. Yeah, so we're talking about fast automation of producing housing parts for battery packs. So our materials have or show very low tolerances, low shrinkage, no warpage, and virtually no moisture uptake. Yeah, so you don't want any of your parts changing, of course, shape. Yeah? So you can scale up faster your pack design. A third important point would be weight reduction. Yeah, so for the portfolio that's available also to ALBIS for these applications, we usually offer materials that are not reinforced. Yeah, so because the mechanical properties of our materials do not change or they don't go reduce during the battery operational temperature range. Yeah, so with this, you can, of course, reduce the weight of your parts, and you can, work towards a more compact battery design. Yeah, without losing, of course, ductility for snap fits and brackets to assemble your pack more efficiently. Another, of course, important topic could be, and as you probably know, is the temperature distribution or the temperature management of the pack. Yeah, this is, of course, directly connected to the cell life and the battery life of your vehicle. So we have also in our portfolio thermally conductive polycarbonates. Yeah? So these are polycarbonates that have a thermal conductivity of around 7 times higher of a conventional plastic, roughly speaking. Yeah, we do have a portfolio for this. And these materials can be used inside of the pack, let's say, an example in a cell holder, to decrease or to enhance the temperature flow of the battery while charging and discharging. And lastly, the polycarbonates and the blends that we offer for these applications, they can be easily post-processed, so by ultrasonic welding or laser welding, and again enabling other kind of functional integration as well. So with this being said, I wanted to show you some examples of where our polycarbonates are used in battery packaging applications, taking into account these key points that I mentioned before: a safety and compact battery design, temperature distribution, but mainly very important is the dimensional stability that our materials bring to these applications, which is certainly very important. One example could be where our materials are used are cylindrical cell holders. Yeah. So, and these what our material brings to this kind of applications is not only good flowability, but that you have dimensional precision. This means that your cells should not move in the pack in order to avoid any, of course, catastrophic event. Yeah, so they should be completely fixed. Of course, other example could be clamshells. This is another way of holding cells, for example, cylindrical cells. And also, if you want to have insulate the current collectors, or take into account thermal expansion. If you want to go into thinner wall applications, and you want to, for example, when you use pouch cells, we also do have grades that are specifically, or that could be used for these applications as well, to take in with excellent mechanical behavior and, of course, dimensional stability to account for discharging and discharging. And that also can be used for busbar carriers. Yeah. Another interesting application that where our materials can be used is the big covers for batteries, so the so-called top covers. So our materials can be processed by a long fiber thermoplastic direct processing, yeah, to achieve this rather bigger top covers while retaining the flame retardant properties of our materials. So, as I mentioned before, yes, we do have a portfolio of polycarbonates used for battery packaging applications. Even though we are a raw material supplier, we also wanted to understand a bit better what the application or what the requirements really are. So we developed our own completely functional battery pack. Yeah, this is a proof of concept that is helpful, or that is helping us to perform abuse testing, thermal management testing, introduce clever design features to increase assembly efficiency, among others. Yeah? So this is a 48-volt pack, and we worked on finding out what the best material is for the housing and for the cell holders. For example, for the housing, which is you can see as the white part on this figure here, the external housing, let's say. Of course, we have materials in the macrolon family and the Bayblend family that could be used, and mainly, or one key point is that these materials are flame retardants. Yeah, they have a high impact resistance. high thermal stability up to, for example, for the macrolons case, up to 145 degrees. And of course, while retaining dimensional stability. Yeah, and some of in our portfolio we have grades that, as I mentioned before, are tailored to be used in thin walls when you want to do specifically design features to increase, of course, the mechanical behavior of the pack. Regarding the cell holders, yeah, we also designed these upper and lower cell holders that you can see on the figure on the slide. Okay. There was some little interruption. It's okay, we continue. For the cell holder applications or cell holder parts in the packs, we have materials in our Macrolon and Babeland portfolio that have, as I mentioned before, impact resistance, mechanical, high mechanical properties, but are also clear for UV curing. And this is an additional part of our portfolio that we also bring for this kind of parts. So you can use UV curable adhesives, for example, to enhance or speed up your mass assembly. Yeah, so we have this in our Macrolon portfolio and our Babeland portfolio as well. Yeah. Another interesting topic that I mentioned before is thermal management. We have, as I mentioned, we have a thermally conductive macrolons that we have tested already for cell holders that so far as preliminary results, and we keep working on this and understanding the behavior of or the battery pack behavior. But so far, after 2 times charging the pack, they have reduced the cell temperature by around 2.4 degrees Celsius. Yeah, and these, of course, you know, when you do the math, there is a rule of thumb that says that these can save the cell life by half. Yeah, so these are things that we explore, and these are portfolios that are available to ALBIS, and you know, we're happy, of course, to support and to exchange. It's not only about battery pack or battery housing applications. We also work on understanding what the other parts of this ecosystem other needs are, like, for example, for the electric powertrain part of the vehicle. Yeah. So an example that we wanted just to bring here that you can observe in the slide is a vehicle control unit. And this is something that I would encourage you to exchange with ALBIS about the solutions that we offer for electric powertrain applications. So in this slide, I wanted to show us an example that for vehicle control units, we have solutions for what you can see there, a cover. You know, we have in our portfolio glass-filled macrolons and Babelands that could be used for this, or also for the connector, we offer blends, as Iman mentioned before, of PC, PET, or so-called macro blends. And also for the bottom part of the vehicle control unit that you can see, the white part, we could suggest the use of thermally conductive macrolons, or as it's pointed there, macrolon TC, yeah, that are also materials that are electrically insulating. Yeah, so this is also to enhance the thermal management of these kind of applications. And again, as I mentioned, this is available to ALBIS, and we're happy to exchange. And this brings me directly to our vision. Yeah, so when we talk, our vision is that we will be fully circular. And this is completely or very well connected to the electrification of the transport or mobility sector. And this is the message that we wanted to also bring today. Yeah, how we empowering with our materials, how we enable this transition. And the way we do this, we have 3 different work streams for this to achieve the circularity. One is mechanical recycling. Yeah, so macrolons or Babelands can have post-consumer or post-industry recycled content. Another work stream is renewable attributed polycarbonates. yeah, which I'll mention in a second. And another work stream is design for sustainability. So we have available also design guidebooks to help you enhancing the design towards making sustainable applications or parts. Yeah. But as I mentioned, we focus for these applications that we talked about today in renewable attributed polycarbonates. And what does this mean? So as Iman mentioned before, yeah, we have a portfolio, well-known portfolio, where with Macrolon, with APEC, Waveland, and Macroblend. And what we have right now is we have a complementary portfolio where that you can see, I hope, in this slide, with a suffix RE. Yeah, this means that these grades, this complementary portfolio, it has renewable attributed. These are renewable attributed polycarbonates, or renewable energy attribution to polycarbonates. And what this brings actually to your application are three main points. Yeah, this portfolio is done in order so you reduce your carbon footprint of your applications. And the three main points that these grades bring is, first, these grades have a biocircular attributed share of up to 70%. Yeah. At the same time, you can reduce the CO2 footprint, as I mentioned, by 3.2 kilograms of CO2 per kilogram of polycarbonate. Yeah. And lastly, very important is that these are drop-in solutions. So you need zero implementation effort to bring these materials into your processing. You don't have to adjust any already set up processing, and these materials have exactly the same properties as the, let's say, predecessors. With this, I would like very much to conclude like with this message of saying that we can make the world a brighter place with our more sustainable polycarbonates, yeah? And that we have this portfolio also available to ALBIS, especially for being used in EV chargers, in battery packaging applications, and in electric powertrain, and that we're happy to discuss. And I would say thank you very much for your attention. We're open for questions.
Thank you. Thank you, Heliana. Thank you, Iman. And you're joined now by two further colleagues for the questions. This is Dr. Konstantin Schwecke and Jimena Ruesta. So 4 people, very a lot of competence here, and I'll just give you the questions because we have to finish in time. So the first question is, does your material fulfill the IK10 test? Now, I don't know what the IK10 test is, but I'm sure you'll be able to tell me and answer the question. One of you just shout.
Yeah, maybe I can take this question. Actually, IK test is a kind of an impact test, which there is a ball drop test, and then you see how the material is performing, how the finished part is performing during this test. And 2 major factors is important in this test. One of them is the material. The second one is the design. So if you have the right material to be used for these tests, then it comes to the design. And that is why we always talk with our customers regarding the part design to make sure that they have the part design which is correct and they can fulfill this IK test. Yes, with polycarbonate, you can fulfill this IK test. You can fulfill it at room temperature and also at minus temperature. The important point is that you have the right design and right material in order to fulfill these impact tests.
Perfect. Thank you for this very concise answer, Iman. Now, the next one is, could the RE materials also be used for battery packaging applications? Who could answer that one?
Yes, I guess I can answer that one. Yes, we are working on even enhancing our RE portfolio, and we have already grades available that are RE that could be used directly for battery packaging applications with no effort. So they are drop-in solutions, as I mentioned before. So.
Perfect, great. Thank you, Heliana. And the third one is, are materials used for smaller packs different in electric vehicle packs?
Yeah, so the pack that I showed in the presentation is a pack for a light vehicle, so it's a rather smaller pack. When you use this kind of packs for a smaller vehicle, they're mostly you need to take, they're swappable usually, so their impact resistant properties are different because you're going to handle them. They're going to be different than the requirements that you will need probably in an electric vehicle. So yes, there are different requirements. It depends on, of course, on the application and how at the end the pack will be handled and used.
Yeah, I got that. Thank you. Now, the last question is, as it is a new topic for polycarbonates, are there already any applications in the market made by polycarbonate in the electric powertrain? Who could answer that one?
Yes, I could take this one. I think it's not a secret to say that the hurdle is very high for polycarbonates in the electric powertrain, and people intend to use materials which they already know from the past, from the combustion powertrain, for example. And I'm not allowed to talk about each application, but what I can tell you is that we have polycarbonates in the powertrain, in the electric powertrain, and it's not that much in the moment. It's a new topic, as already mentioned, and we're quite optimistic that we can find more application for that. We need a cooperation with ALBIS and the customer of ALBIS, and we would be happy to discuss this together with ALBIS.
Thank you, Konstantin. And thank you all four of you for the talk and for taking the questions. And I think we'll leave it here. See you next time, and thanks a lot. Bye-bye to COVESTRO.
Thank you very much.
Thank you. Bye.
Thank you. Bye.
Thank you. So now this sadly brings us to the last part of our day here. But before I ask, they already do that, before I ask Horst and Stefan to join me here for our last reflection, let me tell you that if you have any further questions, don't hesitate and just get in touch with your individual ALBIS contact, and they will be very happy to answer you. And this is where I'm supposed to talk to, right? Now, if you don't have an ALBIS contact yet, you can find them really easy at their sales offices and their ALBIS daughter companies as well, and in the different countries on the ALBIS website. So very easy to find them. Just go ahead, lots of answers around there. So, Horst and Stefan, good to see you again here. I'm sure your head feels just as full as mine does. It's really hard to coordinate all the information we just got in. So what do you make of it? What are you taking away from all that information you've just heard here? What was the most interesting thing you heard, Horst?
That's a tough one. I think it was a very condensed information in a short period of time. I learned, for example, about electronic density that is enabling to free space in components. I think it's a big thank you from ALBIS to all the presenters. I could see that was well prepared. It was very well structured. It was also very well presented. We've seen really very professional slides. And it was good to see already the first dialogue that is happening from this. And I'm sure there will also be some follow-up to this afternoon. So for me, as heading the ALBIS team, definitely mission accomplished.
That's great. And Stefan, what are you taking home? What message?
Well, I see a bright future for electric mobility. And it's so important that this future needs to be shaped in collaboration. It needs to be shaped of all players involved in every dimension, in every perspective. And I mean, this was a wonderful event where collaboration took part, yeah? Presenting, discussing, raising ideas and questions and addressing these questions, because this is an uncharted waters, yeah, as we are saying. And believe it or not, there are in many cities outside of Germany, there are exit strategies. And many countries already have announced exit strategies. And exit strategy means they forbid very close from now on in 2024, the first cities, internal combustion engines. So the market is not only here, I think it will explode in the near future. So bringing people together in these events is essential to be successful and sustainable in these futures.
Well, that sounds promising and great. So what are the next steps, Horst, for ALBIS?
Yeah, well, there are many. And of course, today we think big, but then we start small. We have prepared a flyer where we summarize all these product solutions in a printout version. And we're going to mail this digitally to all participants of this afternoon of this event.
That's
very pragmatic, hands-on.
Very pragmatic, something you will receive either today or tomorrow even. So that's correct. That's great. Thank you. Now, so thanks for everyone for joining us. Thank you for our listeners, for our audience on the screens. Thank you for bearing with us. Stay tuned with ALBIS. We have a few events coming up, and as we mentioned earlier, there will be a sequel of the Healthcare Lounge in October, one day before the K Fair in Düsseldorf, and lots more to come. So lots more opportunities for you to stay tuned with ALBIS, really. And for now, then, take care from all of us. Have a wonderful Tuesday.
Thank you very much.
And moin moin. Yeah. Bye bye. Thank you.
Moin.
Bye bye.
Bye.
Bye-bye.